Hello there, and welcome to our channel, where curiosity gets cozy and the past unfolds slowly enough to fall asleep to. Tonight, I'd like to take you somewhere far back in time, to a world that once ended in fire and began again in the quiet. The story we're stepping into isn't about the towering dinosaurs that ruled the Mesozoic age, but about what happened next when the small, the overlooked, and the underestimated creatures began to rise. Because after all, the roaring stopped, the scurrying began, and in that silence, something new started breathing life into the world. So, wherever you're listening from tonight, perhaps curled up under a blanket or watching the glow of a late lamp, take a moment to imagine the Earth not as it is now, but as it was 66 million years ago, when mammals inherited the night. And if you find this gentle wander through the ancient world soothing or quietly fascinating, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this calm little corner of science find others who need a soft story before sleep. Now settle in, breathe slowly, and let's begin. Because the world we know was once a very different place, and it all started when the night was the only safe time left to live. Before mammals truly took over, they were small, cautious creatures living in the long shadow of the dinosaurs. For over 150 million years, they survived beneath the feet of giants. They were quick and quiet, mostly nocturnal. Their lives are spent in burrows, under leaves or among roots. They didn't roar or rule. They waited. And then one day, or rather one night, everything changed. About 66 million years ago, an asteroid roughly 10 kilometers wide entered Earth's atmosphere at tremendous speed. It struck near what's now the Yucatan Peninsula in Mexico. The impact released energy billions of times greater than any modern bomb. And within seconds, everything within hundreds of kilometers was incinerated. Shockwaves flattened forests, tsunamis raced across oceans, and the sky filled with molten rock. The heat alone would have been unbearable, but the aftermath was worse. Dust, ash, and soot rose high into the atmosphere, blocking sunlight around the world. Photosynthesis faltered, temperatures dropped, days dimmed into a long twilight. In a sense, Earth's light was turned off. The great age of reptiles ended not in a single moment, but in months and years of cold, hunger, and ash. Without sunlight, plants withered. Without plants, various dinosaurs starved. And without them, the great predators followed. What remained were the small, the buried, the hidden, the ones that could eat anything and live anywhere. In this darkened world, mammals found their opening, not through power but through patience. Imagine a landscape stripped bare, the smell of char and dust hanging in the air. Trees stand as blackened skeletons. The air is cooler now, quiet, except for the faint rustle of creatures in the undergrowth. Somewhere beneath the ground, in the safety of tunnels, small, warm-blooded animals stir. They've been here all along, but now, for the first time, the night belongs to them. These early mammals were nothing like the lions or elephants we know today. Most were no larger than mice or shrews, covered in fur with sensitive noses and sharp senses. Some were insect eaters, others scavengers, and a few omnivores that could adapt to whatever they found. In a world stripped of certainty, adaptability became the new form of strength. What allowed them to survive when the dinosaurs couldn't? Part of the answer lies in their biology. Unlike reptiles, most mammals can regulate their body temperature internally. This ability, endothermia, meant they could stay active even when the environment cooled. They also reproduced differently. Mammalian mothers produced milk, allowing their young to grow in a more controlled way, less dependent on external food sources. Their young were nurtured, protected, hidden. When danger was everywhere, that parental care made all the difference. For tens of thousands of years after the impact, life struggled. Entire ecosystems had to rebuild from the ground up. But mammals, with their small size, flexible diets and rapid reproduction, were ready to fill every gap left behind. Some climbed trees, others returned to the open ground, and a few even took to the water. Step by step, night after night, the balance of life shifted. The age of dinosaurs had been ruled by dominance, but the age that followed was ruled by resilience. The mammals that survived weren't just the ancestors of one type of animal, they were the seeds of many. Among them were the early placentals, small creatures whose descendants would one day include primates, rodents, bats, and even whales. There were marsupial relatives as well, clinging to survival in southern continents. And then there were the monotremes, egg-laying mammals like the ancestors of today's platypus and echidna. Strange holdovers from an older world, still quietly thriving. Each of these lineages carried something essential, a kind of evolutionary toolkit for a planet starting over. Picture the forests returning. It took millions of years for the world to regenerate, but once it did, the stage was set. Plants evolved quickly, filling the landscape with new diversity. Flowering plants spread widely, giving rise to fruits and seeds that enticed hungry mammals. Insects flourished again, offering a steady food supply. The earth warmed, climate stabilized, and the survivors began to explore beyond their burrows. In this renewed world, mammals were no longer side characters. They were pioneers in an open frontier. As night turned to day again, mammals adapted to both. Those that once crept under the cover of darkness began to explore the sunlit world. Their eyes adjusted, their behavior changed, and new species emerged, each a tiny experiment in survival. Some became specialized diggers, some lepers, some swimmers. Natural selection, always patient, began to sculpt the small and simple into something varied and vast. In many ways, mammals thrived not because they were superior, but because they were flexible. Dinosaurs had ruled a stable, predictable world. Mammals inherit a broken one, and in brokenness, flexibility wins. They could shift diets, adapt to cold, hide from predators, or find new sources of food. Where one environment collapsed, they found another. That pattern of adjusting, innovating, enduring became their defining trait. One that still echoes in the way mammals live today. By the time 10 million years had passed since the asteroid, the planet was unrecognizable. The outlines of new forests traced the continents, mountain chains rose and eroded, and rivers cut through the land. In North America and Eurasia, mammals grew larger, their bodies experimenting with new forms. Herbivores appeared with grinding teeth for leaves and grasses. Carnivores evolved sharper senses and coordinated hunting behaviors. What began as tiny, shrew-like creatures diversified into hundreds of forms, each exploring a new ecological path. In the ancient wetlands of what's now Wyoming, strange hoofed animals roamed, while in tropical forests, early primates leapt through branches. In South America, marsupial predators filled roles similar to cats and wolves. On the southern continents, monotremes and marsupials continued their quiet persistence, cut off from northern competition by oceans. Each landmass became its own experiment in mammalian evolution, shaped by isolation, climate, and chance. But before the rise of those recognizable forms, there was still a long period when the night truly did belong to mammals. During the first several million years after the extinction, most of Earth's larger species were gone. The sky was quieter, the oceans were strange and recovering. The nights, however, were full of movement. Small mammals hunted insects, dug for roots, and nested in the safety of burrows or tree hollows. Their senses, especially hearing and smell, were their greatest tools. Many could detect predators long before they were seen. Others communicated through chirps, scents, or vibrations. These traits, shaped in the dark, would remain in their descendants long after the world brightened again. The fossil record from this period tells a story written in fragments, tiny jaws, teeth, and bones found in ancient sediments. Each fossil reveals the slow but steady rise of complexity. We find evidence of mammals diversifying into new dietary niches, some teeth adapted for crushing insects, others for ignoring seeds, others for slicing meat. It's as if evolution, suddenly given a blank canvas, began sketching ideas at an accelerated pace. Among these early experiments was a group called the multituberculates, rodent-like mammals that dominated for tens of millions of years. They were small, adaptable and successful, living through periods of climate fluctuation and competition. Eventually, true rodents and primates would outcompete them. But for a long time, they were the quiet rulers of the mammalian world. Their persistence illustrates how much of early mammal evolution was about endurance rather than dominance. Imagine standing in a nighttime forest 50 million years ago. The air is warm and thick with a smell of vegetation. There are no familiar animals, no birds you'd recognize, no human sound. Instead, there are rustles and faint squeaks in the undergrowth, the soft tread of furred feet on damp soil. In the canopy, small eyes gleam as creatures leap between branches. On the ground, insect-eating mammals dig with clawed hands, their nostrils twitching. The nights are alive, but softly so, a living echo of an Earth in recovery. Even the sky, though familiar, held different stars. The continents were not where they are today. South America and Africa had already drifted apart. India was moving toward Asia. Australia was pulling away, carrying its unique lineage of marsupials with it. The oceans swirled differently, and global temperatures were higher than now. In this warm world, mammals expanded with the climate, following forests north and south. The tropics stretched far beyond their modern boundaries, allowing life to flourish almost everywhere. Over time, this quiet revolution in biology began to shape everything. Mammals didn't just survive, they transformed ecosystems. By consuming insects and plants, they affected which species thrived. By spreading seeds through their droppings, they helped forests regenerate. By digging burrows, they aerated soil. Their very behavior changed landscapes, turning destruction into renewal. It's easy to think of this time as distant or alien, but in a way, it's the origin of the world we still live in. The balance between predator and prey, the rhythm of day and night, the interconnected webs of forests and fields, all were re-established during this age. Mammals weren't just adapting, they were rewriting the rules of life on Earth. The planet itself continued to shift. Volcanic activity released greenhouse gases, warming the atmosphere and encouraging vegetation growth. With more plants came more food, and with more food came larger mammals. This was the quiet beginning of gigantism's return, a process that would unfold slowly, setting the stage for the megapora of later epics. But at this point, mammals still kept their distance from true grandeur. They remained modest in size, clever in behavior, and quietly opportunistic. The world they shaped was not peaceful, but it was balanced. Predators hunted prey, plants reclaimed land, and the cycles of life stabilized again. In that stability, diversity flourished. Every ecosystem from the damp forest floor to the open plains offered new possibilities. The mammals took them all, not in a rush, but gradually, generation after generation, each one testing a new adaptation. And so from the ashes of catastrophe, the mammal story began not with dominance, but with endurance. The night that once hid them became the canvas for their survival. The darkness that once forced them to hide became the stage where evolution rehearsed for the daylight. What followed next was a slow expansion, a rise from the shadows into the open world where fur and warmth and care would reshape the planet forever. The world that followed the fire was fragile, quiet, and strange. Imagine the Earth just after the impact had faded into memory, when the heat had cooled and the smoke had thinned. but the marks of destruction were everywhere. The air carried a faint metallic tang from the dust of vaporized rock. The oceans had turned a muddy grey-green from sediment, stirred by the waves of the tsunamis. The forests that had once been dense and towering were gone, reduced to barren trunks and black soil. The sky was no longer a bright blue dome, but a dim veiled stare with clouds heavy with ash. There were days when the sun appeared as a pale disk, and others when it didn't appear at all. This was not yet the planet of mammals, but the Earth in recovery, still trembling from what it had endured. The asteroid that struck 66 million years ago was not simply a large rock. It was an event that reset the entire biosphere. Scientists have found the thin layer of iridium-rich clay that marks the boundary between two ages, the Cretaceous and the Paleogene. That thin layer is the line between the world of dinosaurs and the world of mammals, a geological scar only a few Saturn thick, but representing the end of millions of years of life's dominance by one lineage. Beneath it are fossils of creatures that would never return, and above it are the traces of those that survived. Every grain of that layer tells a story of fire, impact, and darkness. In the months after the collision, temperatures plummeted. Without sunlight, photosynthesis nearly stopped, and global ecosystems collapsed. Plants withered, food chains broke, and large animals starved. The seas cooled and acidified as carbon from the fires dissolved into the water. Coral reefs died, plankton populations crashed, and even the smallest marine creatures struggled. Yet life, as it always does, found a way to persist. Deep sea vents, underground burrows, and thermal springs became sanctuaries. Insects, fungi, and bacteria continued their quiet work, breaking down the dead and preparing the soil for whatever would come next. Mammals were among those who waited out the disaster underground. They hid in burrows, crevices, or beneath layers of fallen vegetation, feeding on roots, insects, and anything organic they could find. For creatures weighing less than a few kilograms, survival depended on staying out of sight and out of reach of the freezing wind. These small beings didn't know it, but the world above was reshaping itself for them. While the age of dinosaurs had lasted more than 150 million years, this darkened interval lasted only a few centuries, perhaps a few thousand years at most. But that was enough to erase the giants. When the sunlight finally returned, it did not restore the old world. The atmosphere had changed, the forests were gone, and the air carried a heavier balance of gases. The great reptiles were extinct, the food webs shattered. But the small mammals emerged to find opportunity. The Earth's surface, once dangerous and crowded, was now open. There were no more giant predators, no enormous herbivores stripping the vegetation. The land was quiet and the silence was full of potential. In those early years, life began with simplicity. Ferns were among the first plants to reclaim the land, sprouting in dense mats across the burned soil. Their spores traveled easily, and their growth didn't depend heavily on seeds or pollinators, which have been devastated by the catastrophe. Ferns are often the first to return after forest fires even today, and back then they covered entire regions, transforming the blackened landscapes into green again. They were soon followed by hardy flowering plants that could tolerate variable light and temperature. These pioneers laid the foundation for the new ecosystems that mammals would inherit. The mammals that stepped cautiously into this recovering world were not all alike, but they shared a few key traits. They were small, warm-blooded, and mostly omnivorous. Their teeth tell the story of adaptability. Some for grinding plants, others for cutting flesh, still others for cracking insect shells. Their diets shifted with the availability of food, which was crucial when stability was rare. These mammals bred quickly with litters that matured fast. Short lifespans, high reproduction, and flexible diets allowed them to respond to change faster than any other large animals could. The night was still their ally. Even after the great predators were gone, the daytime remained risky. The sun's rays were harsher under the thinner ozone layer, and the temperatures fluctuated wildly. Many mammals preferred to stay hidden during daylight, emerging at dusk to forage. This continued the long habit of nocturnality that had helped their ancestors survive the reign of the dinosaurs. Their eyes attuned to low light, and their sensitive whiskers and ears gave them an advantage in the darkness. The world after the fire was dim, and the mammals were ready for it. Slowly, as vegetation returned, so did diversity. Insects adapted rapidly, feeding on decaying material and new plant growth. With insects came their predators. Mammals that could catch and eat them prospered. The first ecosystems to stabilize were probably those near water, where plants grew quickly and offered shelter. Lakes and rivers became cradles of new life. Amphibians, reptiles, and fish recolonized them. But mammals lurked at the edges, hunting along the muddy banks. In these quiet places, evolution's next chapter began. The Earth warmed again after its brief winter. Over the next few million years, the climate shifted toward a greenhouse phase. Carbon dioxide from volcanic activity and decomposition accumulated in the atmosphere, trapping heat. Rainfall increased, forests spread, and with warmth came abundance. The Paleocene epoch had begun. What had once been an ashen wasteland was now a lush, humid world covered in tropical forests from pole to pole. In this reborn environment, mammals multiplied rapidly. By this time, the survivors had already begun to diversify. Some species developed longer limbs for running, others sharper claws for climbing. Teeth evolved for new diets. Flat murs for grinding vegetation, serrated ones for tearing flesh. Brain size gradually increased, especially in species that relied on sight and hearing rather than sheer instinct. The mammals that had once been simple scavengers were now exploring every available niche. Evolution was no longer crawling, it was sprinting. The world itself reflected this restless growth. The continents were already recognizable, but not yet in their modern positions. South America and Africa were drifting apart. North America was separating from Europe. India was on a collision course with Asia. The Atlantic Ocean was widening, and ocean currents were shifting, creating new weather patterns. These changes didn't just move land, they moved life. Forests migrated with the climate, animals followed food sources, and populations became isolated, setting the stage for new species. In North America, mammals like Prungulatum, a small herbivore, grazed among ferns and early flowering plants. In what is now Europe, insectivores scoured through dense underbrush, hunting beetles and larvae. In Asia, small primate-like creatures began appearing in the canopy. Each continent hosted its own quiet experiment in adaptation. The diversity we see today, bats, whales, elephants, primates, rodents, all trace their lineage back to these first experiments in the Paleocene. The world after the fire was one of contrasts. There were stretches of land still barren, where erosion stripped away the topsoil and rivers carved new valleys. There were regions that bloomed uncontrollably, thick with vines and trees competing for light. The atmosphere was richer in carbon and the temperatures could soar. Life in this era had to be adaptable not only to scarcity, but to excess. Mammals evolved to regulate their body heat efficiently, using fur as insulation and sweat glands for cooling. Their internal temperature control made them resilient to these wild fluctuations, and that trait became one of their greatest advantages. It's easy to imagine this period as a gentle regrowth, but it was also a time of chaos and experimentation. Evolution doesn't plan ahead. It tries, fails, and tries again. Some mammals developed odd forms that would later vanish from the record. There were small herbivores with hooves, but no close modern relatives, predatory mammals with long bodies and short limbs that hunted like weasels, and early bats that had wings but couldn't yet decorate. The variety was immense, and only a few lineages would persist into later epochs. Yet this explosion of forms laid the groundwork for everything that followed. For several million years, mammals remained small, rarely larger than a cat. But the absence of large reptiles left empty roles in ecosystems. Gradually, evolution filled them. Herbivores grew bulkier to digest tough plants. Carnivores became faster and more coordinated. These new adaptations took time, tens of millions of years. But the process began here in the world that had risen from the fire. Meanwhile, in the oceans, life was recovering as well. Marine reptiles were gone, but mammals would one day return to replace them. The ancestors of whales and dolphins were still land animals then, small, hoofed creatures that preferred wetlands and riverbanks. Birds, descendants of small surviving dinosaurs, took to the skies and diversified rapidly. The planet that had once been ruled by reptiles now had a new rhythm. Mammals on the ground, birds in the air, both shaped by the same forces of change. Even as life expanded, traces of the disaster never fully disappeared. The layer of iridium remained buried in the rocks, a silent reminder of the catastrophe that started it all. The ecosystems that emerged were fragile, still vulnerable to change. Volcanic eruptions, shifting climates, and meteor strikes continued to challenge life. But the mammals endured. Each challenge honed their adaptability. As forests thickened, some mammals began to specialize in climbing. Their limbs rotated more freely, their claws adapted for grasping, and their tails became tools for balance. In the canopies, fruit and insects offered new food sources. The first primate-like animals emerged from this arboreal world, small, alert, and social. Their descendants would one day look back on this age with curiosity, but for now, they were simply part of the great rebuilding. The land that had been burned to ash was now alive with movement again. Rain fell on green leaves, rivers carried sediments rich with nutrients, and the air was thick with the buzz of insects. The mammals that had once hidden from the light now thrived in it. The world was no longer ruled by fear, but by adaptation. If one could walk through this world, it would feel familiar, yet alien. There would be no grass underfoot. Grasses hadn't yet become dominant. Instead, ferns, cycads, and flowering shrubs covered the ground. The air would be warmer and heavier, filled with the calls of early birds and the rustle of mammals in the brush. At night, the forests would glow faintly under a bright moon, and the air would hum with the quiet persistence of life rebuilding itself. This was the dawn of a new era, not in sudden light, but in gradual warmth. From devastation emerged from abundance, from silence, song. The mammals didn't conquer the earth in a rush. They grew into it as the world itself grew back from its wounds. Every step forward was shaped by what had burned before. And as the forest deepened and the air filled with the rhythm of countless small hearts beating in the dark, the world that had ended began again. Different, smaller at first, but destined for greatness. The age of mammals was underway, and the ashes of the past had become the soil of the future. The age that followed was dim and delicate, a time when shadows stretched longer than sunlight and life moved carefully beneath them. After the great fires and floods, after the skies had cleared just enough for the sun to return, the world entered a long period of quiet rebuilding. The land was still recovering, the climate unstable, the balance between day and night uncertain. Yet in that uncertainty, small creatures found their strength. The mammals that had survived the catastrophe were creatures of the dark, adapted to stillness and silence. They had outlasted the worst by burrowing deep, eating what others ignored and listening more than they moved. Now, as the earth exhaled and cooled, they began to shape the new world in ways unseen and slow. Imagine standing in a forest not long after the first plants had returned. The ground is soft with new ferns, their green delicate and bright against the black soil. The trees are young, thin and sparse. Their leaves tremble in a wind that still carries the faint scent of ash. The air hums with insects, not yet in the billions, but enough to remind the world that life continues. Somewhere beneath the roots, in hidden burrows and tangled tunnels, mammals are stirring. Their world is small, a few meters of soil, a patch of moss, a network of hiding places, but it is enough. In this shadowed earth, survival belongs to those who can live unseen. Most mammals at this time were nocturnal, their eyes large and sensitive, adapted to catch the faintest glimmers of light. They could navigate the darkness with a kind of quiet precision, guided by smell, touch, and sound rather than sight. Their ears were fine-tuned to the rustle of leaves, the flutter of insects, the crack of a twig. Whiskers, once a minor feature, became vital tools, mapping their surroundings in constant motion. Their brains, though small, were quick, processing information at speeds that allowed them to react before danger reached them. In the absence of size and strength, awareness became survival. They lived close to the ground, feeding on beetles, worms, and seeds. Some gnawed on fallen nuts, others hunted larvae beneath bark. Their diets were simple but sufficient. Omnivore became the key to survival, a willingness to eat anything edible and a metabolism ready to make use of it. Their fur provided warmth through the chill nights and insulation from the still, cooling ground. For the first time in Earth's history, small, warm-blooded animals were not just surviving. They were thriving. The darkness that had once been their refuge now became their domain. With most reptiles gone and birds only beginning to diversify, mammals found the night free of competition. Predators were few and the temperature stable enough to allow safe foraging. Their populations grew. In evolutionary terms, this was an explosion not measured in sudden leaps, but in steady persistence. Each generation carried subtle changes, slightly sharper teeth, longer limbs, better senses that over countless cycles transformed entire species. Among these survivors were the ancestors of many modern lineages. Some were tiny insectivores, similar to today's shrews, scurrying through the leaf litter in search of prey. Others resembled early marsupials, carrying their helpless young in pouches as they foraged. A few small herbivores experimented with grazing on tender shoots, beginning the long lineage that would one day give rise to grazing mammals and even ungulate. In the fossil record, their names appear as whispers. Emaya, Purgatorius, Prulatum, small bones that tell of a world moving cautiously toward the future. The environment itself was a blend of old and new. The continents, though slowly drifting apart, were still close enough to share similar climates. Much of the Earth was covered in humid forests, though patches of open land existed where new plants struggled to grow. Temperatures were generally warm, but nights could be cool and damp, perfect for the small mammals who preferred to venture out after sunset. Rain fell frequently, feeding streams that wound through ferns and young trees. The soil was rich in nutrients from decayed matter, and every storm brought new life. In these damp forests, the mammals' greatest strength was not their size, but their ability to keep their internal world stable. Their warm blood allowed them to function in varying temperatures. Their constant activity, keeping their bodies balanced, even when the environment shifted unpredictably. Reptiles and amphibians, still dependent on the warmth of the air, struggled in the cooler nights. Mammals didn't wait for the sun. They created their own heat, carried their own weather inside them. It was a quiet revolution in biology, invisible to the eye, but profound in its consequence. The night also shaped their minds. With limited visibility, their behavior became guided by sound, scent, and memory. They developed routines, returning to the same feeding grounds, following familiar paths through the undergrowth. Some formed small family groups, cooperating in the search for food or protection of their young. Others remained solitary, wary of competition in a world where resources were still scarce. Communication evolved gradually, soft chirps, squeaks, and scents marking territory or signaling danger. Each adaptation layered another thread into the complex fabric of mammalian behavior. Predators did exist, though none as dominant as the reptiles of old. Some early birds of prey hunted at dawn, their sharp eyes scanning for movement below. Snakes had survived too, gliding through the underbrush, their patience unmatched. These dangers kept mammals cautious and clever. Every sound was a signal to freeze or flee. Over time, this vigilance refined their nervous systems, sharpening reflexes, enhancing awareness. Their brains began to prioritize quick decisions, memory, and learning, traits that would later define the intelligence of their descendants. The life of a small mammal in that age was brief but eventful. They matured quickly, bred often, and died young. Their genes passed on in a constant cycle. Evolution moved fast through these short generations, experimenting relentlessly. A slight change in limb length, tooth shape, or sensory perception could decide which lineage thrived and which disappeared. Over millions of years, this ceaseless fine-tuning produced new species with specialized abilities. Some became adept climbers, gripping bark with flexible digits. Others evolved digging claws, turning soil in search of insects. A few developed the beginnings of gliding membranes, launching themselves between trees under cover of darkness. While most of the Earth remained warm, the climate was not uniform. Volcanic activity still shaped regions, releasing gases that warmed the atmosphere but also caused local disruptions. Forest fires smaller than the great one that ended the Cretaceous were common. Each disturbance created new ecological opportunities. When trees fell and sunlight reached the ground, new plants grew, attracting herbivores. Where fire cleared underbrush, open spaces emerged, and mammals that favored running adapted to use them. Nature was constantly resetting and rebalancing, and mammals learned to move with it rather than against it. Their reproduction was another quiet advantage. Unlike reptiles that laid many eggs and left them, most mammals invested heavily in fewer offspring. The development of milk provided a reliable food source for the young, ensuring better survival rates even when external conditions changed. This parental care required time and energy, but it paid off. Each new generation entered the world stronger and more capable. In evolutionary terms, care became power. The fossils from this era are small and often fragmentary, yet they reveal remarkable detail. Tiny teeth preserved in river sediments show wear patterns that tell us what these creatures ate. Jawbones reveal how muscles are attached, indicating how they chewed. Inner ear bones, delicate structures, show an increasing refinement of hearing, suggesting an adaptation to nocturnal life. Each fossil is a clue, and together they paint a picture of a world where sight was secondary, but sound and scent ruled. This was also a time when ecosystems began forming new connections. Fungi thrived in the decaying plant matter, recycling nutrients into the soil. Insects fed on the fungi, and mammals fed on the insects. With each link restored, the web of life grew stronger. The Earth that had nearly died was now pulsing again with interdependence. Every creature, no matter how small, played a role. Some of the earliest mammalian predators appeared during this time as well. They were small but efficient, using stealth rather than strength. Their teeth evolved into specialized forms in sizes for gripping, canines for piercing, murs for shearing. They hunted insects, amphibians, and other small mammals, establishing the ancient dynamic of hunter and prey that would define ecosystems for the rest of Earth is history. The night became a silent battlefield of movement and counter-movement, of soft sounds and sudden stillness. Meanwhile, the plant world was undergoing its own revolution. Flowering plants diversified rapidly, spreading through wind and animal pollination. With flowers came nectar, and with nectar came insects adapted to feed on it. This in turn attracted mammals that fed on insects and fruits, weaving their fates together. Seeds began to evolve structures that encouraged dispersal through animal digestion, creating partnerships that would last millions of years. Mammals became gardeners of the planet without knowing it, carrying seeds in their fur and droppings to new lands. As forests expanded, new microclimates appeared. Dense canopies created shade and humidity, while open edges offered warmth and food. Mammals moved between these zones, some staying low to the ground, others climbing higher. Arboreal life encouraged new adaptations, better balance, flexible limbs, and keen spatial awareness. The earliest tree dwellers set the stage for future primates and other arboreal species, all emerging from these same small survivors who learned to live among shadows and branches. Everywhere, life was still cautious, but it was learning. The planet had entered a long twilight between catastrophe and abundance. Evolution doesn't rush, it adjusts. The mammals that lived in this age were not aware that they were laying the foundation for future giants, predators, and thinkers. They were simply surviving in a world that asked for patience. And yet, even in their stillness, the world around them was preparing for change. The air was warming, vegetation thickening, and ecosystems stabilizing. The long night that had once protected them would eventually give way to daylight, and those who adapted to the sun would inherit a very different Earth. But for now, the shadows were enough. In them, the mammals perfected the art of quiet endurance, learning to live between danger and safety, darkness and dawn. The age of shadows was not a pause in evolution, but its steady heartbeat. Every heartbeat added a new thread to the fabric of life that would one day fill the earth with endless variety. From their burrows, hollows, and nests, the small survivors continued their patient work of being alive, turning the ruins of one age into the beginnings of another. And as the forest deepened and the nights filled with the faint hum of countless small lives, the world waited for what would come next. The moment when the creatures of the night would finally rise into the sun and begin to claim the open world above. The rise from the burrows began quietly, as most great changes in nature do. There was no single moment, no day, when the mammals decided to leave the darkness behind. It happened slowly, through generations of cautious movement, one poor step at a time. The world had warmed again, the forest had thickened, and the sun no longer burned with the harshness it once carried after the fires. The soil was soft and alive, with roots and insects. The air shimmered with moisture and the hum of new life. It was no longer a world of survival alone, but a world that invited curiosity. And curiosity, in the quiet logic of evolution, is the first step toward expansion. The mammals that had spent millions of years beneath the ground or in the shelter of night began to explore the surface more boldly. Some emerged earlier in the evenings, staying out longer into the twilight. Others lingered into the mornings, their bodies adjusting to the rhythm of daylight. Over time, their eyes adapted, their senses broadened, and their behaviors shifted. The creatures that once secured between shadows began to stand, sniff the air, and look around. The burrow, once the boundary of safety, became just a starting point. The earth they entered was different from the one their ancestors had hidden beneath. The forests had grown dense again, lush and tangled. Ferns spread like carpets beneath the trees, and vines climbed toward the sunlight, filtering through the canopy. Flowers had returned in dazzling abundance, each one part of a new, intricate web, connecting insects, birds, and small mammals. The world no longer smelled of ash. It smelled of earth, pollen, and rain. It was a living labyrinth rich with sound and movement, and the mammals that ventured into it found both risk and reward. Small herbivores began to forage in the open. Their diets expanded to include fruits and leaves, not just seeds or insects. Their teeth changed accordingly. Molars grew broader and flatter, able to grind the fibrous plants that now filled the forest floor. These early grazers became the ancestors of ungulate, the hoofed mammals that would later roam open plains. For now, though, they were still small, nimble creatures weaving through undergrowth, wary of the returning predators that hid among the ferns. Carnivorous mammals followed closely behind. Some were opportunistic scavengers, feeding on carrion left by snakes or early predatory birds. Others learned to hunt, relying on stealth rather than strength. They were low to the ground, sleek and silent. Evolution favored those with quick reflexes and sharp senses. In these early hunters lay the seeds of future predators, cats, canines, and others yet to come. The relationship between hunter and prey was reawakening, each shaping the other in a slow, endless cycle. But the story of the rise from burrows wasn't only about competition, it was also about exploration. For millions of years, mammals had lived in tight spaces, confined to tunnels and hollows. Now, with the world open again, they began to fill it. Forest canopies offered food and safety, and some species climbed with increasing skill. Their limbs became more flexible, their claws more curved. A few even developed gliding membranes between their limbs, allowing them to leap from tree to tree. The forest night was no longer limited to the ground. It extended into the air. Life in the trees demanded intelligence. Navigating branches required coordination and memory. Animals needed to judge distances, plan routes, and recognize safe pathways. This encouraged the growth of larger, more capable brains. In this way, the rise from burrows was not just physical, it was mental. The mammals were learning, adapting not only in form but in thought. Their behavior became more complex. Some began to form social bonds, cooperating to raise young or defend territory. Communication through sound and scent became increasingly refined. What had once been a simple existence of hiding and feeding now held traces of awareness. The world around them continued to change in tandem. The Paleocene epoch was giving way to the Iowine, a time of warmth and abundance. Temperatures rose globally, and forests stretched farther north and south than ever before. Even the poles were covered in green, with subtropical vegetation thriving where today there is ice. This expansion of forests created corridors of life across continents. Mammals spread through these corridors, migrating, mingling, and diversifying. The burrows were no longer enough to contain them. The planet itself had become their home. In this lush environment, evolution accelerated. Within a few million years, the variety of mammals had multiplied dramatically. There were small, mouse-like creatures darting through the underbrush, larger herbivores browsing on leaves, and agile climbers in the canopy. The fossil record from this time reveals the rapid appearance of many familiar groups: early primates, early hoofed animals, and even the ancestors of modern whales. Still walking on land, but already showing hints of adaptation to water. Each lineage was an answer to a different question posed by the changing world. The open exploration of the surface also brought new challenges. Exposure to predators meant that vigilance became essential. Mammals developed acute senses, not just for finding food, but for detecting danger. Their eyes evolved to perceive motion. Their noses could track scents over long distances, and their hearing grew sensitive enough to detect the faintest rustle. Every sense became a survival tool, and together they made mammals masters of awareness. The climate's warmth supported diversity, but it also tested resilience. Periodic fluctuations in temperature and rainfall forced species to migrate and adapt. Some evolved specialized diets, focusing on particular plants or insects. Others remained generalists, capable of shifting between foods as needed. In times of scarcity, omnivory was a lifesaver. The ability to eat fruit one day, insects the next, and roots the following week meant survival in an unpredictable world. Reproduction also adapted to this new era. Mammals that had once raised their young in secluded burrows began to build nests or dens above ground. The act of caring for offspring became more visible, more social. Mothers defended their litters fiercely, and in some species, fathers participated in care. The bonds formed through this cooperation strengthened group structures. These relationships would eventually give rise to the complex social behaviors seen in many mammals today. From wolves hunting in packs to primates grooming one another in trust and companionship, the physical landscape of the Earth was also transforming. Continents drifted farther apart, shaping ocean currents and climate patterns. Mountains rose, rivers carved new valleys, and coastal regions shifted. These geological forces created isolated environments where populations evolved independently, resulting in a patchwork of ecosystems. Each one became a crucible of innovation, producing unique species suited to its particular conditions. In the northern forests, small primic mammals thrived. Their grasping hands and stereoscopic vision are perfect for navigating branches. In open regions, herbivores developed stronger limbs and faster running speeds. In the wetter lands, early semi-aquatic mammals began venturing into water, hunting for fish and crustaceans. This diversity of habitats encouraged specialization, and specialization drove evolution forward. The rise from burrows was also the beginning of mammals reclaiming the day. For tens of millions of years, they had been creatures of the night, relying on stealth and caution. Now, as the skies brightened and the forests stabilized, some species dared to embrace daylight. Their eyes adjusted, their behavior shifted, and their patterns of activity changed. The sunlight that had once been dangerous became an ally. It offered warmth for thermoregulation and vision for exploration. The first diel mammals appeared, breaking a pattern that had defined their kind since the time of dinosaurs. This return to the light didn't erase their nocturnal heritage. It built upon it. The sharp hearing and keen sense of smell developed in the dark remained, giving even daytime species extraordinary awareness. Their brains integrated multiple sensory inputs, enhancing perception and decision-making. These abilities laid the foundation for the advanced cognition seen in modern mammals. Intelligence in this sense was not an invention of complexity, but an accumulation of survival strategies refined in both darkness and light. The Essen world was teeming by now. From small tree-dwelling primates to fast-running herbivores and carnivores, mammals filled every corner of the landscape. The oceans, too, were changing, with some land mammals beginning their gradual transition into fully aquatic life. These early ancestors of whales were called archivolts, four-legged hoofed creatures that hunted along shorelines. Over millions of years, their descendants would abandon the land entirely, becoming creatures of the sea once more. The rise from burrows had extended not just upward into the trees, but outward into the oceans. Birds were also flourishing, competing with mammals in some niches, but coexisting in others. The skies filled with color and song, the forests with sound and movement. Predators and prey continued their evolutionary dialogue. Each innovation met with a countermeasure. Speed was met with agility, camouflage with sharper vision. The balance of life was dynamic, constantly shifting, yet remarkably stable in its overall harmony. Fossils from this period show that mammals were growing larger. For the first time since the extinction, body size increased significantly with abundant food and stable climates. Being larger offered advantages: longer lifespans, better thermoregulation, and fewer natural predators. Some herbivores reached the size of modern sheep or small deer. Carnivores followed suit, evolving stronger jaws and limbs for tackling bigger prey. The age of small survivors was giving way to a new era of confident expansion. And yet, for all their progress, the memory of the burrows lingered in their instincts. Many mammals still dug nests or dens, returning underground to rest or raise their young. The safety of the Earth was encoded in their behavior, a reminder of the time when the world above had been deadly. The burrow remained a symbol of continuity, a connection to their origins, even as they reached for the light. It's humbling to think that every mammal alive today carries traces of that ancient transition. The preference for darkness in certain species, the instinct to dig, the patterns of sleep and wakefulness all have roots in those first steps out of the soil. Even our own human ancestors, millions of years later, would inherit that same blend of curiosity and caution, the balance between safety and exploration that defines all life. As the Eocene continued, mammals became the undisputed architects of ecosystems. Their feeding shaped vegetation patterns, their movement dispersed seeds, and their burrows and nests altered soil composition. The once dominant reptiles were now secondary players in a world orchestrated by fur, warmth, and care. The Earth had entered a new rhythm, one driven not by size or armor, but by intelligence, adaptability, and endurance. The rise from burrows wasn't a revolution. It was a long exhalation, a gradual awakening from the dark. It was the sound of tiny feet on new soil, of rustling leaves and cautious breaths. It was a million small decisions made over millions of years, each one a choice to venture a little farther from safety. Out of those choices came everything that followed. The great migrations, the towering mammals of later epochs, and eventually the creatures capable of wondering how it all began. And as the sunlight fell gently across a world once lost a shadow, the mammals continued their slow and steady climb. The Earth, for the first time in tens of millions of years, belonged to them. And though they didn't know it, the long night that had sheltered them was finally over, replaced by an age of warmth, growth, and endless possibility. The world that unfolded after the mammals began to climb from their burrows was still haunted by ghosts of giants. For a time, Earth carried both memory and presence, the last echoes of the age that had ended and the first murmurs of the one just beginning. The great reptiles were gone in body, but their legacy lingered in every landscape, in the empty spaces where their weight had once pressed the soil, in the ancient forests that had been shaped by their browsing, and in the silence left behind by their extinction. The planet was full again, but it had changed. Life had learned humility in the shadow of catastrophe. And from that humility came something entirely new. An age not of dominance, but of balance. Even millions of years after the impact, the Earth bore its scars. In some regions, layers of ash still rested beneath new soil, rich in minerals that nourished the returning forests. Rivers had carved new paths through landscapes flattened by shock waves. Mountain chains had risen higher under the slow movement of continents, and weather patterns were shifting towards stability. The air was warmer, the rain heavier, and the vegetation denser. It was a world in recovery, not static, but alive with motion. And within that motion, mammals continued their quiet expansion. They were still small, at least compared to the giants that had come before. But in evolutionary terms, smallness had become an advantage. It allowed speed, flexibility, and efficiency. While the dinosaurs had relied on size and specialization, mammals thrived through adaptability. A species that could survive in one habitat could often adjust to another. When food ran short, they migrated or shifted diets. Their success lay not in grandeur, but in resilience. This was the world of small dreams, creatures that lived close to the ground, each one contributing to the gradual reshaping of life. Yet even as these small mammals prospered, the last remnants of the giant age were still fading. Crocodiles and turtles, holdovers from the Mesozoic, continued to rule rivers and swamps, their lineage nearly unchanged. In the skies, birds, descendants of dinosaurs, had taken over the ecological roles once filled by their reptilian ancestors. Eagles, Cranes and early waterfowl filled the air with motion, mastering the realm of flight that mammals had not yet conquered. For the first time since the catastrophe, the balance of ecosystems stabilized, food webs were formed, complex and interdependent. Plants spread through pollination and seed dispersal, aided by mammals and birds. Insects multiplied in astonishing numbers, feeding on the new vegetation and providing nourishment for the creatures that hunted them. The forest grew thick, and the cycle of life resumed its patient rhythm. In this period, mammals diversified at a rate unmatched in previous ages. The fossil record shows new species appearing every few hundred thousand years, each slightly different from the last, each testing a new strategy. Some mammals grew larger, their bodies adjusting to a diet of leaves and fruits. Others remained small and specialized, digging for insects or ignoring en routes. The earliest primates were leaping through trees, their hands already capable of grasping branches. Hoofed mammals, still primitive, were beginning to experiment with speed and endurance. Carnivorous species hunted by stealth, perfecting the art of patience. The Earth was alive with possibilities, and yet it was not peaceful in the sense we imagine. The forests were dense, but full of competition. Every inch of soil, every patch of sunlight, every drop of water was contested. But the struggle was quiet, measured, and balanced by abundance. Unlike the age of dinosaurs, when a few dominant species shaped entire continents, this was an age of shared existence. Countless small creatures lived side by side, each finding its niche. It was an Earth of many lives rather than few rulers. The climate played a guiding hand in this transformation. Global temperatures reached their highest point in tens of millions of years, and the poles were free of ice. Tropical conditions extended into regions that are now temperate. Rainforests covered vast areas of the continents, providing an almost endless array of environments for life to explore. In this greenhouse world, plants and animals adapted to warmth, humidity, and stability. The diversity of mammals reflected this richness. Each adaptation, no matter how minor, found a place somewhere. Still, the age of giants wasn't entirely over. While dinosaurs were gone, other enormous creatures began to emerge in their absence. They were not as large as the titans of the Mesozoic, but by mammalian standards, they were impressive. Herbivores, such as early proboscideans, the distant ancestors of elephants, appeared in Africa and Asia, their bodies stocky, their teeth adapted for chewing coarse vegetation. In South America, relatives of modern sloths and armadillos began to grow in size and number. These were the first steps toward the eventual return of the large mammals. But for now, they shared the world with countless smaller species that filled every corner of the ecosystem. In this world of contrasts, size no longer dictated success. A small mammal could be as ecologically important as a large one. Insects depended on them for predation, plants relied on them for pollination or seed dispersal, and other animals used their abandoned burrows as shelter. The very structure of ecosystems became more complex, more layered. Every level of the food web intertwined with the next. It was also a world of sound. The forests were alive with chirps, calls, rustles, and hums. Mammals, birds, insects, and amphibians filled the air with constant movement. Communication evolved rapidly through scent, through touch, and increasingly through voice. The development of vocal cords and complex auditory systems allowed mammals to express alarm, recognition, or courtship in ways far more subtle than before. This early language of sound became another evolutionary advantage, one that would later lead to intricate social structures. The Earth's surface was dynamic, but its deeper layers were shifting too. Continental drift slowly reconfigured the oceans and land masses. The Atlantic widened, separating North America from Europe. India's collision with Asia began lifting the Himalayas, altering wind and rainfall patterns. These tectonic changes, though slow, shaped climates and habitats, driving migration and isolation. Each isolated population evolved along its own trajectory, resulting in distinct fauna across continents. In one region, primates flourished, in another, hoofed grazers dominated. Diversity was both local and global. Among the smaller species that thrived in this new world were early rodents, whose efficient teeth and quick reproduction allowed them to adapt almost anywhere. They became the great generalists, feeding on seeds, fruits and insects, and reproducing rapidly enough to recover from losses. Their presence was transformative as they became a crucial food source for predators and a vital link in the ecological chain. Alongside them, bats made their evolutionary debut, mastering the skies at night. With wings formed from stretched skin and elongated fingers, they became the first mammals to conquer flight, using geolocation to navigate and hunt in darkness. The night, once ruled by silence, was now alive with wings. The mammals that evolved in this era were not just survivors. They were architects of the new world. Through their feeding, movement and nesting, they shaped the environment. Herbivores trimmed vegetation and spread seeds. Predators controlled populations and kept ecosystems in balance. Borrowers aerated soil, influencing the growth of plants. Each behavior had a ripple effect, creating feedback loops that stabilized the planet's living systems. The Earth was learning to breathe again through its creatures. Yet even as life flourished, the memory of extinction remained imprinted in the natural order. Evolution is cautious after catastrophe. The systems that developed were resilient but restrained, designed not for excess but for endurance. Where once species had grown enormous and dominant, now they tended toward adaptability. This restraint made the biosphere more stable, less vulnerable to sudden collapse. It was as if the planet itself had learned from its own fragility. The small dreams of this age were not the grand visions of titans, but the quiet ambitions of persistence. The mammals built their world not through conquest, but through coexistence. A forest mouse seeking food at dusk, a lemurica creature grooming its mate, a mother nursing her young in a hollow tree. These were the architects of the new age. Each action, however simple, contributed to the continuity of life. And yet in the grand scope of evolution, change never rests. The warm world of the early Eocene would not last forever. Over the next millions of years, climates would begin to cool again. Forests would retreat, grasslands would spread, and mammals would face new challenges. But in this period of balance and abundance, the foundations had been laid. The Earth had shifted from a world of giants to a world of thinkers, nurturers, and survivors. The rise of intelligence, of emotion, of care, all of it can be traced back to this time when life slowed down enough to learn complexity. When size no longer guaranteed safety, adaptation did. When dominance gave way to cooperation, the seeds of social behavior took root. In burrows, nests, and family groups, mammals began to develop the early frameworks of empathy and communication. Evolution had moved beyond the mechanics of survival and begun to experiment with connection. In these forests, ancestors of modern primates navigated the canopy with precision, their eyes set forward for depth perception. Their hands are capable of gripping branches with dexterity. Their lives were social and interactive. Bonds formed not merely for reproduction, but for mutual care. This shift, small in appearance, was profound in consequence. It introduced the idea that survival could be shared. Elsewhere, large herbivores browsed peacefully in groups, their movements shaping the vegetation. Early carnivores stalked quietly nearby. Their success depends on strategy rather than strength. Each adaptation reflected a world in equilibrium where no single species could dominate indefinitely. The giants of the past had ruled through scale. The mammals of the present ruled through balance. The fading of the old order was not mournful. It was natural. The Earth was shedding an outdated design for one more intricate and enduring. The bones of the dinosaurs lay buried under new soil, their legacy transformed into fossil fuels and minerals that would one day fuel the energy of another curious mammal. Life does not discard its history, it recycles it. The world of giants had burned brightly and briefly. The world of small dreams would burn quietly, but far longer. As the millions of years passed, this quiet persistence built momentum. The mammals' influence grew, shaping environments and creating networks of life that could bend, but not break. They had replaced brute force with flexibility, specialization with cooperation, dominance with adaptation. The planet itself seemed calmer under their stewardship, more sustainable, more diverse. It is remarkable to think that the foundation for all of this, every living mammal, every human thought was laid during this time of transition. The fading of giants made space for the rise of consciousness. The silence left behind by extinction became the canvas for complexity. Out of the ashes of one world, another had grown, not in the image of power, but in the image of persistence. And so, as the forest deepened and the days lengthened, the mammals continued their slow and certain spread. The earth no longer echoed with the footsteps of giants, but with the subtle, rhythmic sounds of countless small lives. Their dreams were not of conquest or glory, but of survival, care, and curiosity. In those dreams, the world found a new kind of greatness. The rise of mammals was never just a story of survival. It was a story of invention, one that began deep within the small, beating warmth that separated them from the cold-blooded world they had left behind. When the dinosaurs vanished, the earth cooled, and the air lost its stability. Nights grew longer, mornings unpredictable, and yet mammals thrived. Their secret wasn't armor, venom, or size. It was something far more subtle, almost invisible. It was the ability to carry their own heat, to build a fire within their bodies that would never go out. Warm-bloodedness or endothermia seems simple when we think of it now. Every breath we take, every beat of our heart, every flicker of energy in our muscles depends on it. But for the early mammals, it was an evolutionary revolution. It meant independence from the environment. Where reptiles needed sunlight to awaken and warmth to move, mammals could act in darkness, in cold, in uncertainty. They could hunt while others slept, search for food while the ground was damp and cold, nurture their young even when the air chilled. This internal warmth was more than a biological trait. It was the foundation for everything that followed. The origin of this ability is still partly hidden in the fossil record. It likely began long before the asteroid fell, deep in the lineage that led to the first true mammals. Ancient theropods, sometimes called mammal-like reptiles, showed early signs of it. Thicker bones for muscle attachment, evidence of faster metabolisms, and changes in their nasal passages suggesting the presence of warm, moist air regulation. These were clues that the machinery of heat production was already beginning to hum inside them. By the time true mammals appeared, the process was refined. They were small, but their bodies were engines of energy. Inside every mammal, this engine works in remarkable balance. Heat is created through metabolism as food is broken down and transformed into energy. To maintain a stable internal temperature, the body adjusts constantly, expanding blood vessels to release heat when it's warm, contracting them to conserve it when it's cold. Muscles shiver to generate warmth, hairs rise to trap air, sweat cools the skin. The system is automatic, but it's also expensive. To stay warm, mammals must eat more, move more, and live more actively. It's a costly trade-off, but one that pays in freedom. That freedom shaped everything. In the ancient forests of the Iowine, warmth meant survival when temperatures dropped at night. It meant activity when others were still, endurance when conditions changed. Mammals could colonize colder regions, move into higher altitudes, and explore new climates. This adaptability gave them a reach that no reptile could match. The world once divided by temperature was now open. But the invention of warmth was more than physiology. It changed behavior, rhythm, and even the pace of life itself. Mammals needed constant fuel, so they developed efficient ways to find and store food. They became active for longer hours. Their senses are tuned to detect opportunities and threats. Their hearts beat faster. Their respiration quickened. Their muscles became capable of sustained motion. The world of stillness and waiting had been replaced by one of movement and awareness. Warmth also shaped emotion in ways subtle but profound. The close contact between mothers and offspring during nursing, the instinct to seek touch and proximity, and the comfort found in shared heat. All of it built the foundation for social bonds. To be warm-blooded was to carry the potential for connection, both physical and emotional. While reptiles could abandon their eggs to the sun, mammals carried their young within, fed them with milk, and shared warmth as a form of protection. The internal fire became not only an engine of metabolism, but a metaphor for care itself. The fossil evidence of this era reflects this biological revolution. Bones grew lighter but denser, designed for agility. Teeth diversified to handle richer diets, fueling faster metabolisms. The development of a secondary palate allowed mammals to breathe while chewing, ensuring a constant supply of oxygen for their active bodies. Skull structures indicate larger brain cavities, supporting the coordination needed to manage temperature regulation and complex behavior. Each adaptation spoke to a life lived on its own internal schedule, no longer dictated by the external rise and fall of the sun. In the thick forests of the early Eocene, this warmth created a world of endless motion. Small mammals scoured under leaves, constantly foraging to feed their burning metabolisms. Predators stalked tirelessly, their bodies powered by the same internal heat that fueled their prey. Even in sleep, warmth meant safety, the ability to remain alert, to wake quickly, to flee at the first sign of danger. It was a world of perpetual readiness, driven by invisible fires. At the same time, warmth demanded rest. For all its benefits, it required recovery. The cycles of sleep became an integral part of mammalian life, allowing the body to restore energy and maintain balance. These rhythms, waking, eating, sleeping, became part of the natural order, aligning with the world's own cycles of light and dark. Mammals, though free from the tyranny of temperature, remained connected to the rhythm of time in another way. Through their internal clocks, the steady beat of life is sustained by warmth. The relationship between body temperature and behavior was intimate. When early mammals ventured into cooler regions, they adapted by thickening their fur, by altering blood flow, by developing layers of fat for insulation. In tropical zones, others evolved ways to release heat efficiently. The diversity of these solutions mirrored the diversity of the environments they lived in. Evolution was not creating one type of mammal, but many, each tuned to its surroundings through the shared foundation of warmth. Some lineages took this adaptation further. Bats, for example, learned to manage their energy by entering torpor, a state where metabolism slowed to conserve heat during rest or cold conditions. Others, like early primates, developed behaviors that used warmth socially, huddling for comfort, grooming to maintain fur insulation, sleeping in groups for shared protection. In each of these, warmth was both a biological mechanism and a behavioral strategy. This era also saw the refinement of homeostasis, the ability to maintain internal stability. Mammals could regulate not just temperature, but blood chemistry, hydration, and energy levels with precision. Their nervous and endocrine systems worked in concert to balance every process. It was as though life had gained a new form of control, a self-awareness written into physiology. This internal order reflected a deeper principle: survival through harmony rather than reaction. In the context of the planet's climate, this adaptability was critical. The Earth's warmth was not uniform. Seasonal changes grew more pronounced, and periodic cooling events tested the limits of endurance. Cold snaps could kill reptiles or insects, but mammals weathered them, retreating to dens and maintaining body heat through metabolic persistence. Each of these events filtered life, favoring those who carried the fire inside. Endothermia also opened the door to exploration beyond the tropics. For the first time, animals could inhabit northern forests, mountain valleys, and cooler coastal zones. This expansion spread mammalian species across continents, leading to isolation and diversification. Populations separated by geography evolved independently, giving rise to unique forms adapted to their climates. Some grew thick coats and compact bodies to conserve heat. Others became sleek and lean to dissipate it. The result was an explosion of diversity that mirrored the planet's own environmental mosaic. It's striking to think that such vast changes stemmed from something as simple as body heat. The warmth that began as a biochemical adjustment became the engine of ecological transformation. Through it, mammals reshaped entire biomes. Their presence altered vegetation, soil structure, and even atmospheric composition. By consuming and redistributing plant matter, by digging, by breathing, they contributed to cycles of carbon and oxygen that stabilized the planet. The warmth inside them connected to the warmth of the Earth itself. In this same period, the development of fur became essential. Fur was not merely a covering, it was technology, a living insulation that trapped air close to the skin, maintaining temperature efficiently. Its evolution coincided with the growth of specialized glands that produced oils for waterproofing and scent for communication. The relationship between skin, fur, and heat regulation defined the external identity of mammals. Every strand of hair served a purpose, an extension of the warmth within. Another quiet revolution was unfolding within their hearts. The mammalian circulatory system became a masterpiece of endurance, a four-chambered heart ensuring oxygenated blood reached every organ with precision. Combined with lungs capable of high-volume exchange, this system powered continuous activity. The same heart that beat in a small shrew pulsing rapidly through the night would millions of years later beat in whales the size of buses. The design scaled seamlessly from the tiniest creature to the largest because the principle was the same. Warmth through circulation, energy through flow. The mammals' sensory systems were also intertwined with this new metabolism. Warmth enhanced activity, and activity demanded awareness. Eyes adapted to varying light conditions, ears refined for subtle frequencies. Noses tuned to scent molecules carried on humid air. Their perception of the world was vivid, multidimensional and constant. Unlike reptiles that relied on bursts of energy, mammals lived in a continuous stream of experience, always processing, always feeling. In social species, this continuity fostered emotion. Emotional responses, fear, comfort, affection were extensions of physiological states tied to the regulation of warmth and energy. The same chemistry that managed temperature, managed stress, bonding, and calm. Hormones like oxytocin and cortisol balance survival with connection. The mammalian heart didn't just pump blood, it set the rhythm for feeling. As the expense progressed, mammals used this energy to expand into roles that had never existed before. Some species developed large grazing habits, shaping grassland ecosystems before grasses had even fully evolved. Others became apex predators, combining endurance with strategy. Each innovation was supported by the same internal mechanism, the constant, dependable flame of metabolism. Even in times of environmental disruption, the warmth persisted. When climates cooled, mammals retreated temporarily, but never vanished. Their physiology gave them time to adapt, to migrate, to evolve. They were no longer at the mercy of external conditions. This stability was a profound shift in the relationship between life and the planet. For the first time, organisms could shape their own fate, not through external defense, but through internal control. It's possible to imagine an early mammal in the chill of dawn, breathing mist into the air, heart beating fast as it searches for food among the leaves. Around it, the forest hums quietly, still wet from night rain. The air is cool, but its body is steady, warm against the world. It does not wait for the sun that carries the sun within. That image, simple and ancient, captures the essence of this age. A world learning that survival could come from within, that warmth could replace armor, that life could endure not by resisting change, but by internalizing balance. And in that warmth lay the blueprint for everything that would follow, for the care of a mother, for the thought of a mind, for the persistence of species that would cross ice and desert, mountain and sea. The secret engine that began as a way to survive the cold became the silent reason life could dream beyond it. The world that warmth created was not silent. With every heartbeat and breath, with every step taken into the dense living forests of the Eocene, life began to listen more closely. Warmth had given mammals the endurance to explore, but it was their senses that allowed them to understand the world they had entered. The earth was alive with sound, scent, light, and texture. To survive here, it wasn't enough to move. One had to perceive, to feel the rhythms of the forest, to read its invisible signals, and to respond to them with precision. What had begun as a biological necessity became something deeper, a symphony of senses that shaped the mammalian way of being. In the beginning, those senses were tools for survival. The early mammals were small and vulnerable, and their continued existence depended on awareness. A rustle in the leaves might mean a predator nearby. The faintest shift in wind could carry the scent of food or danger. Their world was a constant stream of information, and evolution favored those who could interpret it quickly. Hearing, smell, touch, sight, and taste didn't evolve separately. They evolved together, forming a network of perception that turned every mammal into a living sensor tuned to the complexity of its environment. Among the first to refine this system with a nocturnal species for millions of years, mammals had lived in darkness, forced into the night by the dominance of reptiles, their eyes adjusted to low light, their ears to the faintest vibrations. Even after the Great Extinction, when daylight returned, those adaptations remained. The night was still theirs. It was quiet, cool, and full of opportunity. In that darkness, hearing was everything. The structure of the mammalian ear is one of evolution's most elegant solutions. Within it lies a delicate chain of three tiny bones, the malleus, incus, and stapes, that transmit sound from the outer world to the inner cocina. This trio is unique to mammals and marks one of the most significant transformations in vertebrate history. The ancestors of mammals, those early therapsids, had once used parts of their jaw to hear. Over time, as the jaw became specialized for chewing, these bones shifted inward, evolving into instruments of exquisite precision. By the time true mammals emerged, they could detect higher frequencies, subtler tones, and complex patterns of sound. This change reshaped not only how they heard, but how they communicated. Sound became a bridge between individuals, a way to warn, attract comfort, or locate one another. In a dark forest where vision failed, a single chirp, squeak, or growl could mean the difference between safety and death. The forest at night became a layered orchestra of calls and responses, a living composition of survival. Smell was no less important. Long before vision became dominant, scent was the language of the world. Air carried stories, and mammals learned to read them. Through chemical cues, they could detect predators, find food, identify kin, and recognize territories. Their noses were not merely openings for air, but elaborate sensory systems lined with receptors that translated invisible molecules into meaning. The olfactory bulbs of the brain, responsible for processing smell, were among the largest structures in early mammals. They received a constant stream of information from the environment, moist soil, decaying leaves, flowering plants, and other animals. A single inhalation could reveal direction, distance, and danger. Even today, in the animals that inherited this sensitivity, dogs, bears, elephants, the world is still primarily a world of scent. It's a reminder that before sight became our dominant sense, smell was the first way life began to map its surroundings. Touch, too, became a foundation of mammalian life. Fur was not just insulation for warmth. It was a living network of sensation. Each hair follicle was connected to nerves that could detect movement, temperature, and pressure. Whiskers, vibrae, were especially sensitive, acting as antennas that read the shape and texture of the world. A small mammal could navigate a tunnel in complete darkness, guided only by the faint vibrations in the air and the brush of its whiskers against the ground. This tactile awareness was so precise that it became an extension of thought itself, an unconscious form of perception that allowed movement with grace and confidence even when the eyes were closed. Taste evolved in parallel with smell, refining the ability to distinguish what was safe to eat and what was not. Bitter compounds warned of toxins, sweetness signaled energy, salt indicated essential minerals. Together, smell and taste created the foundation of mammalian feeding behavior. The act of eating was no longer a matter of chance. It became guided by an intricate feedback loop between the senses and the brain. Food was evaluated not only by its availability, but by its chemical story. And then there was vision, perhaps the most complex and transformative sense of all. For early mammals, sight was limited. Their ancestors had lived in dim light, and their eyes were optimized for sensitivity rather than sharpness. But as some species ventured back into daylight, vision underwent a renaissance. The retinas of mammals evolved new structures, adjusting to brightness and color. Some lineages developed cones capable of perceiving multiple wavelengths, allowing the first glimpses of the colorful world that flowers and fruits were creating. Depth perception improved as eyes shifted toward the front of the head, giving predators and climbers alike the ability to judge distance with accuracy. Among the first to fully embrace this new sense were the primate ancestors who lived in trees where sight meant survival. To leap between branches required precise spatial awareness, and to find ripe fruit demanded color recognition. The mammalian eye became an instrument not just of detection, but of decision. With it came the beginnings of curiosity, the ability to look, interpret, and wonder. All these senses worked together, feeding into the growing complexity of the mammalian brain. The expansion of sensory regions led to greater integration, where information wasn't just received, but analyzed, compared, and remembered. This capacity for sensory memory meant that mammals could learn from experience. A certain sound could recall danger, a certain smell could signal food, a certain texture could mean safety. Behavior became guided by memory as much as by instinct. In the quiet hours of the night, these abilities turned the forest into a living network of awareness. Each rustle was noted, each scent catalogued, each sound interpreted. The mammals moved through their world like musicians in an orchestra, attuned to every note, every rhythm. The forest itself became a sensory landscape, layered with signals, visible and invisible, audible and silent. Communication deepened alongside perception. Vocalization became increasingly complex. Simple alarm calls evolved into varied tones, indicating different threats. Mothers developed distinct calls for their young, and young learned to recognize them instantly. The range of sound frequencies mammals could produce expanded, allowing emotional nuance to emerge. Comfort, warning, aggression, affection all found their expression through sound. The same was true for scent communication. Glands in the skin, especially around the face and tail, produced chemicals used for marking territory and signaling reproductive readiness. These invisible messages carried meaning long after the sender was gone, transforming the environment into a map of social information. The air and the ground themselves became part of the mammalian communication network. This sensory sophistication was not just functional, it shaped behavior, emotion, and intelligence. The brain, constantly fed by streams of sensory data, grew more capable of making connections. Problem-solving emerged, curiosity expanded, and social complexity increased. A mammal could not only react to its world, but anticipate it. It could learn patterns, remember individuals, and modify behavior based on experience. Over time, these abilities gave rise to something extraordinary, the sense of self, to feel one's body in space, to recognize others, to distinguish between internal and external sensations. These were the first steps toward consciousness. It wasn't awareness as we define it now, but it was the foundation of it. The mammalian brain had become an organ not just of response, but of perception that extended inward as well as outward. The senses also shaped how mammals experienced time. Because they could remember past sensations and predict future ones, their perception of the present became stretched. They lived not just in reaction, but in expectation. This subtle shift altered the rhythm of life entirely. The forest wasn't simply a backdrop for movement, it was a living narrative where each sound and scent was a clue, and every moment carried continuity. The combination of warmth and senses transformed mammals into explorers of complexity. Their survival no longer depended solely on instinct. It depended on interpretation, on reading the world correctly, and adjusting to it with intelligence. Every sense added a layer to that interpretation, making the mammalian experience of life richer, more detailed, and more emotionally nuanced than anything that had come before. Even the smallest mammals, those we might think of as primitive, carried within them this intricate symphony. The hum of their blood fed the rhythm. The beat of their heart set the tempo, and the harmony of their senses composed the melody. They could feel the temperature of the air shift, smell the approach of rain, hear the wings of an owl, and sense the tremor of its landing before it struck. Every moment was alive with information, and every response was an act of understanding. The world of the Eocene was a place where this sensory intelligence thrived. Forests were thick with sound and motion. Rivers carried smells from miles away. Flowers released colors and scents that danced together to attract pollinators. Insects buzzed, amphibians croaked, birds sang, and mammals listened. The environment itself had become an orchestra, and mammals were both its audience and its players. As the apex continued, this sensory complexity only deepened. The evolution of echolocation in bats marked one of its most remarkable expressions. These small mammals use sound itself as a form of vision, emitting high-frequency calls and interpreting the returning echoes to map their surroundings. It was as though evolution, having mastered the visible and tangible, had decided to give mammals a way to see with their ears. In aquatic mammals, hearing adapted again, this time to water. The bones of the ear thickened and reshaped, allowing the detection of vibrations through liquid instead of air. The transition from land to sea didn't diminish the sensory world. It redefined it. Whales and dolphins developed communication systems so complex that even today we struggle to decipher their full meaning. Their songs, spanning miles of ocean, became the next great movement in the symphony of senses. Back on land, primates continued refining sight and touch. Their hands became tools not just for grasping, but for feeling, exploring texture, temperature, and pressure. The fingertips grew dense with nerve endings, each capable of detecting the subtlest detail. This tactile precision combined with vision allowed them to manipulate objects, select ripe fruits, and groom each other with affection and care. Sensation became intertwined with emotion, and emotion became part of the social fabric. The evolution of the senses did not happen in isolation. It shaped and was shaped by the world around it. Plants evolved to attract mammals with bright colors, rich scents, and sweet fruits. Predators evolved camouflage to avoid detection, and prey evolved warning signals to deter attack. The entire biosphere became a web of sensory dialogue. Every organism communicates in its own way. Life was not just living, it was listening. Even now, the legacy of that symphony remains within us. Every shiver, every scent, every flicker of awareness connects us to that ancient lineage. Our eyes, though adapted for daylight, still carry the capacity for night vision. Our ears, though dulled compared to those of our ancestors, still turn instinctively toward faint sounds. Our skin still senses the subtlest shifts in temperature or touch. The warmth within us powers not only life but perception. In the grand story of evolution, the invention of warmth made mammals possible, but the symphony of senses made them conscious of their world. It was through hearing, seeing, smelling, and feeling that they began to understand not just how to live, but what it meant to be alive. And as the forest continued to stretch across the continents and the air filled with the sounds of countless living beings, the mammals carried their awareness forward, refining it, sharing it, and building upon it. From that growing awareness came curiosity, intelligence, and eventually the first hints of wonder. The world had learned to perceive itself through them. And the music of that realization, the quiet, endless rhythm of perception would play on, shaping the course of every heartbeat that followed. The warmth that pulsed inside every mammal was only half the story. The other half was wrapped around it, soft and living, shaped by time and touch. For all their power and adaptation, mammals were never armored like reptiles or feathered like birds. Their strength came from something that seemed fragile, soft skin. Beneath that skin lay a hidden power, a network of glands, follicles, and nerves that not only protected life, but connected it, nourished it, and changed the way the world would evolve. What had once been a simple layer of tissue became one of evolution's most versatile inventions, turning vulnerability into resilience. When the first mammals appeared, their skin was already unlike that of their reptilian ancestors. It was more complex, layered and alive with function. The outermost cells hardened into keratin, forming a protective barrier, while deeper layers remained supple, allowing flexibility and healing. Embedded within were countless hair follicles, each connected to nerves and blood vessels. And at the base of each follicle, tiny muscles that could raise or lower the hair in response to cold, fear, or emotion. This was no passive covering. It was a living interface between the inner world and the outer one, constantly responding, sensing, and adapting. The development of fur was one of the defining traits of mammals. It was the visible expression of warmth, the physical proof of endothermic success. But fur did more than conserve heat. It gave texture to sensation, allowing mammals to feel air currents, vibration, and contact. A light breeze against the skin could convey direction. A shift in pressure could signal danger. Every strand was a messenger. Over millions of years, fur diversified. Thick and oily for cold water, soft and dense for insulation, sparse and short for heat dissipation. It became a tool shaped by environment and behavior. In the humid forests of the Eocene, fur took on new roles. For many species, it became camouflage, blending them into dappled light and shadow. For others, it became a display, marked with stripes or spots that broke up their outlines. Some evolved coats that signaled maturity or season, shifting colors as the year changed. Each variation told a story of adaptation, of form molded by function. The soft skin beneath was always the foundation, the living surface that supported every change. But fur was only one part of the hidden system. Within the skin, Evolution had woven a network of glands that transformed the way mammals interacted with their world. Sweat glands, sebaceous glands, and mammary glands. Each arose from the same ancestral structures, modified to serve new purposes. Through them, the skin became a center of communication, regulation, and care. Sweat glands were among the most important. They allowed mammals to release heat through evaporation, a feature unheard of in reptiles. This simple mechanism made endurance possible. By sweating, mammals could remain active for longer periods, even in heat. It allowed pursuit, migration, and exploration without constant pauses for cooling. Later in certain lineages, including the ancestors of humans, sweating would become one of the defining traits that separated them from every other creature, giving them the ability to run and work in the open sun while others rested. But in these early epochs, the invention was still new, its value quietly unfolding in the rhythm of the forest. Sebaceous glands produced oils that kept fur and skin supple and water-resistant. In aquatic and semi-aquatic mammals, this protection became vital, preventing water from stripping away body heat. In land species, it maintained the delicate balance between moisture and dryness, allowing life to thrive in environments that fluctuated between rain and sun. Even scent glands evolved from this system, turning chemical signals into language. Through subtle variations in these secretions, mammals could identify kin, mark territory, or attract mates. Invisible to the eye, these senses carried meaning across distances, turning the skin into an instrument of communication as intricate as sound. Then there were the mammary glands, the most transformative of all. What began as modified sweat glands became the source of milk, the substance that defined mammals and set them apart from every other lineage. The origin of milk is ancient, possibly predating the first true mammals. Early forms may have secreted nutrient-rich fluids to moisten eggs or nourish hatchlings, long before live birth evolved. Over time, these secretions grew more complex, tailored to the needs of growing young. Fat, protein, sugar, and immune molecules combined in perfect proportion, creating the most advanced biological food source on the planet. The invention of milk was more than a feeding strategy. It was a revolution in reproduction and survival. By nurturing young after birth, mammals freed themselves from the constraints of environmental timing. Their offspring could develop slowly, safely, under the care of a parent rather than the mercy of weather or chance. It allowed learning, protection, and bonding. The act of feeding became the center of connection, linking generations not just through genetics, but through emotion. In the quiet of an ancient burrow, a mother might curl around her newborns, sharing warmth through touch and nourishment through milk. In that moment, the complexity of evolution condensed into simplicity. One life sustains another. The softness of her skin, the warmth of her body, the chemistry of her glands, all work together to ensure continuity. That tenderness built from biological necessity became one of the most enduring patterns in the history of life. The hidden power of soft skin was not limited to care. It also granted adaptability that hard shells and scales never could. A reptile's armor offered defense, but it was rigid, slow to heal, and limited in growth. Mammalian skin, by contrast, could repair itself rapidly, stretch, and change. When injured, its cells multiplied and sealed the wound. When exposed to new climates, it evolved new pigments or thicknesses. It was flexible in every sense, an organ of possibility. Pigmentation became another form of adaptation. Melanin, the molecule responsible for color, not only determines pattern, but protects against sunlight. In regions near the equator, darker skin prevented damage from ultraviolet rays. In cooler climates, lighter tones improved vitamin absorption. Even color variations within species served ecological purposes, camouflage signaling or temperature control. What seemed like decoration was in truth survival written in color. The nerve endings embedded within the skin also brought a new dimension to experience. Mammals could feel not just pressure or temperature, but texture, vibration, and even emotional context through touch. The act of being touched triggered hormonal responses, lowering stress, enhancing bonding, reinforcing social trust. This feedback loop between skin and brain tied emotion to sensation in ways no other lineage had achieved. To touch and to be touched became an integral part of communication, as vital as sight or sound. This tactile intelligence played a major role in social evolution. Grooming behaviors which began as simple cleaning became acts of connection. In primates especially, grooming served to maintain relationships, resolve conflict, and build hierarchies. Each stroke of fur was a statement of reassurance. Even among species that lived solitary lives, touch remained essential between mothers and young. The softness of skin made that communication possible. It was the medium through which affection could be expressed. In aquatic mammals, the soft skin transformed yet again. The fur thinned, replaced by layers of fat for insulation. But the sensitivity remained. Whales and dolphins evolved skin that renewed itself constantly, preventing barnacle growth and allowing smooth, silent movement through water. Their entire bodies became instruments of perception, capable of feeling pressure waves and subtle changes in current. The loss of fur did not mean the loss of connection. It simply shifted the design. As mammals diversified, their skin became a record of their history. Fossils rarely preserve it, but impressions left in ancient sediments reveal fur patterns, gland placements, and sometimes pigmentation. Each fossilized mark is a whisper of the hidden systems that powered life's expansion. Even without bones, the story of soft skin continues through the clues it left behind. Microscopic traces of hair, chemical residues of oils, or patterns etched in stone. The hidden power of skin also shaped how mammals interacted with their environment, because it could sweat, breathe, and sense. The boundary between body and world blurred. Mammals were not sealed off from their surroundings. They were in dialogue with them. The skin absorbed heat, released scent, responded to humidity, and adjusted to pressure. Every breath of air and every drop of water became part of an exchange. It was this permeability, not isolation, that made mammals so adaptable. The softness that protected them was paradoxically their strength. A creature with delicate skin seemed fragile compared to one with armor, but that flexibility meant freedom. It allowed growth, movement, and sensitivity. It meant the world could be felt, not just endured. The survival of mammals depended on awareness, and awareness depended on touch. Over millions of years, this sensory intelligence would deepen further. The same nerves that detected pressure and warmth became linked to pleasure and comfort. The simple act of resting against another body, of sharing heat, became emotionally significant. Entire species built their social lives around contact, nesting together, huddling in groups, forming lasting bonds. What had begun as physiology became psychology. The mammalian world was not one of isolation, but of connection, both physical and emotional. In evolutionary terms, soft skin was an experiment in trust. It invited interaction rather than defense. It assumed that the risks of exposure could be balanced by the rewards of cooperation. Through it, mammals began to build societies, not consciously, but through instinct. The desire to touch, to comfort, to stay near, laid the groundwork for social behavior that would one day define entire civilizations. The story of mammals is in many ways the story of skin learning to feel the world and respond to it. From the first furred bodies that emerged in the dark to the sleek forms gliding through ancient seas, every adaptation spoke of sensitivity turned into strength. Beneath the softness lay an intricate web of biology that made endurance possible. Beneath that biology lay something even deeper, the quiet recognition that connection was as vital as survival. As the Eocene world thrived, the forests thickened and the animals within them evolved ever more specialized forms. Yet through every change, the same softness persisted, carrying its hidden power forward. It was the one feature no mammal ever lost. No matter how large, small, terrestrial or aquatic it became, the skin was always there, the meeting place between life and the world, the first sense and the last defense. And through that skin, through its warmth, its scent, its touch, the mammals continued to write the story of life's resilience, not in bones or scales, but in softness, in care, in the endless conversation between the body and the earth around it. The world had settled into a rhythm. The forests were dense, the air warm and heavy with the scent of life. And the mammals that once crept quietly beneath the leaves were no longer confined to their shadows. They had grown confident. The small, soft-bodied creatures that once secured through burrows and branches now began to move outward, to roam across the earth, exploring landscapes that had been silent since the fall of the dinosaurs. It wasn't a conquest. It was a gradual wandering, a patient expansion shaped by curiosity, hunger, and the gentle persistence of survival. The continents themselves were changing, and with them, the story of life. The plates beneath the ocean shifted, pushing mountains upward and opening new seas. The air moved differently. The rain fell in new places, and the winds carried seeds farther than before. The world that had once been uniform and tropical began to form contrasts. Wet forests, open plains, dry woodlands. Each new habitat was an invitation, and the mammals accepted without hesitation. They roamed. For tens of millions of years, they had lived close to the ground, cautious and small. Now, with the climate stable and food abundant, size and diversity exploded. Herbivores grew larger, predators followed, and the ecosystems that would define much of the Cenozoic took shape. It was the beginning of an age that would later be called the Age of Mammals, not because they dominated in the way dinosaurs once did, but because they filled every possible niche, from canopy to ocean floor, in the humid lands of what would one day become North America. Early ungulate grazed in herds among thick ferns and early flowering plants. They were nothing like modern horses or deer, yet their bodies small, their feet ending in several toes rather than hooves. Their teeth were beginning to adapt for grinding leaves, a sign that grasses were still rare, but that fibrous diets were becoming important. These creatures moved in small groups, cautious but communal, their safety found in numbers rather than armor. Nearby, the first large carnivorous mammals stalked through the underbrush. They were not cats or dogs as we know them, but ancient forms, nimraids, creodonts, and other early predators. They hunted with stealth and hindrance. Their senses, honed by millions of years of nocturnal vigilance, were sharp. Their eyes could catch the faintest movement. Their noses could follow scent trails invisible to any other creature. For the first time since the extinction, the balance between predator and prey was being rewritten, and it was mammals, not reptiles, setting the terms. In Asia, the forest stretched endlessly, home to small primates leaping between branches. Their eyes faced forward now, their hands grasped instead of clawed, and their social lives grew more complex. Living in groups required memory and empathy, skills that would one day lead to intelligence beyond mere instinct. They groomed one another, shared food, and watched for danger together. The canopy had become a city of movement, filled with calls and quiet companionship. Farther south, in what would become Africa, another story was unfolding. The ancestors of elephants, hippos, and other large herbivores began to appear. Their bodies grew heavier, their legs thicker, their teeth specialized for grinding tough vegetation. The forest was still their home, but the seeds of a new kind of life were being planted, one that would someday move beyond the trees across open land. Evolution, slow and silent, was setting the stage for the future. Everywhere the mammals went, they changed the world. As they grazed, they spread seeds through their droppings. As they dug, they aerated the soil, mixing nutrients and reshaping the ground. Their movement created pathways that became rivers of life for insects and plants. Where they drank, watering holes formed. Where they slept, burrows and nests altered the microclimate of the soil. The Earth was becoming an ecosystem shaped not by geology alone, but by the activity of living beings. The oceans were transforming as well. Descendants of small, hoofed land animals had begun to return to the sea. At first, they waded in shallow waters, hunting fish and crustaceans. Over time, their limbs flattened into flippers, their bodies elongated, and their nostrils shifted upward to form blowholes. These were the ancestors of whales, dolphins, and porpoises. They carried with them the warmth of the land, the breath of air, and the intelligence of mammals. The sea, once ruled by reptiles, had new rulers, now gentle giants who sang to one another across vast distances. Back on land, climate and geography continued to shape evolution. The continents were drifting into configurations that would one day look familiar, though their positions were still in motion. South America remained isolated, a world of its own, where marsupials and early placental mammals evolved in parallel. Australia drifted further south, carrying with it the ancestors of kangaroos, koalas, and monotremes. Africa was lush and green, its rivers full and forests deep. Each landmass became a different experiment in mammalian design, separated by oceans, but connected by the same evolutionary rhythm. The mammals didn't spread because they wanted to dominate, but because their biology allowed it. Warmth, fur, and adaptability gave them the tools to survive almost anywhere. In cold climates, thicker coats evolved. In dry ones, efficient kidneys conserved water. They learned to hibernate through scarcity, to migrate through change, to live in deserts, mountains, and swamps. The adaptability that had once saved them in the age of shadows now made them unstoppable. Their senses, refined over millions of years, guided them through every environment. The smell led them to water. Hearing warned them of predators. Touch connected them to one another. The world was no longer something to hide from. It was something to explore. And as they roamed, they learned its language, interpreting every sound, scent, and texture as information. Social behavior deepened during this time. Many mammals began to live in groups, sharing protection and resources. This required communication, vocal calls, body language, scent marking, and touch. Cooperation became an evolutionary advantage. Predators hunted in pairs or packs. Herbivores defended their young collectively, and communities began to form patterns of behavior that went beyond survival. The seeds of culture, in its simplest biological form, were being sown. Some species developed migratory behavior, following food sources across great distances. In doing so, they connected ecosystems that had never interacted before. Seeds from one forest ended up in another. Insects spread between continents via temporary land bridges. Even climate patterns began to shift subtly as herds moved across grasslands and forests, influencing carbon cycles and vegetation growth. The mammals, without intention, became stewards of the biosphere. The rise of large mammals changed everything. Size brought stability. Larger animals could travel farther, store energy, and endure environmental fluctuations better than smaller ones. But it also required more food, more coordination, and greater care. Mothers gestated longer and invested more in each offspring. Parental care, already a hallmark of mammalian life, became central to survival. It wasn't just a strategy, it was a way of life. Predators adapted in kind. The large carnivores that emerged during this period were powerful, agile, and intelligent. They developed strategies that relied on teamwork and patience rather than brute force. Some hunted in pairs, using stealth and timing to ambush prey. Others evolved speed, relying on bursts of energy to chase down targets. The dynamic between predator and prey became a dance of adaptation and counter-adaptation, each side shaping the other in an endless cycle. Every environment bore its own symphony of movement. In temperate forests, herbivores moved along ancient paths, trampling ferns and stirring seeds into the soil. In open plains, new forms of running mammals tested their endurance against wide distances. In coastal regions, semi-aquatic species thrived, dividing their time between land and sea. The diversity was astonishing, and it was still only beginning. This age of roaming was also an age of experimentation. Evolution tried countless designs, some strange, some familiar. There were mammals with long, flexible snouts, others with armored hides, some with elongated limbs for leaping, and others with thick claws for digging. Many of these forms would vanish, their fossils left behind as brief notes in the symphony of life. But every failure contributed knowledge to the process, refining what worked and what didn't. The mammalian brain continued to expand, both in size and in function. The regions responsible for memory, coordination, and social interaction grew more complex. Behavior became nuanced, learning more pronounced. A young animal no longer relied only on instinct. It could observe, imitate, and adapt. Mothers taught their young through example, and groups began to share learned behaviors across generations. The idea of tradition, actions passed on not by genes, but by learning, was beginning to take shape. As the mammals roamed, the earth responded. Plants evolved defenses against grazing, thorns, toxins, tough fibers. Mammals evolved ways to counter them. Some developed specialized stomachs to digest cellulose. Others learned to select plants rich in nutrients. The relationship between flora and fauna became one of mutual shaping, an arms race of adaptation that increased diversity on both sides. The world had not seen such complexity since the late Cretaceous. But now it was of a different kind. Where once dominance had belonged to a few, it now belonged to many. No single species ruled the planet. Instead, life was balanced across countless forms, each influencing the others in an intricate web. It was an age of collaboration as much as competition. The sky above reflected this change. Birds, themselves survivors of the extinction, filled the air in partnership with mammals below. Insects, rejuvenated by new vegetation, became the base of countless food chains. The planet hummed with equilibrium, a steady pulse of life that spread across continents and oceans alike. At night, when the air cooled and the forest quieted, the sounds of mammals filled the darkness, the rustle of leaves, the soft calls of primates, the distant steps of herbivores. They had inherited the night from their ancestors, but they had made it their own. Even under the moonlight, the warmth of their bodies carried forward the same fire that had allowed them to rise from burrows, now lighting the world in invisible ways. Every generation carried the memory of motion. It was written in muscle, bone, and instinct. To roam was to live, to follow the shifting balance of the Earth's abundance. This movement would continue for millions of years, shaping continents, species, and eventually the very nature of evolution itself. In time, these wanderers would give rise to creatures capable of crossing oceans, of standing upright, of gazing at the horizon, and wondering what lay beyond. But for now, they moved without thought of destination, guided only by the quiet logic of survival and the endless pull of curiosity. The age of mammals had learned to roam not with conquest, but with connection, to the land beneath their feet, to the air that carried their scent, to the water that mirrored their forms. Every step they took carried the echo of those who had survived before them, and every new path they found would one day become part of the great map of life. The world was vast, open, and alive again, and the mammals, still humble and soft, continued their slow exploration of it, shaping the planet with every movement, one heartbeat at a time. The world beneath the mammals' feet was never still, even as forests stretched across the continents and herds roamed under humid skies. The ground itself was slowly moving, rearranging the map of life with a patience that no creature could see, but every species would feel. It happened too gradually to notice in a lifetime, too immense to imagine in a single glance. Yet, over millions of years, this slow drift of continents became the architect of everything: climate, landscape, and destiny. The mammals that wandered across this restless Earth were shaped not only by their own evolution, but by the movements of the planet itself. The Oeon had begun as a world of warmth. Tropical forests covered nearly all of it, stretching from pole to pole. There were no glaciers, no frozen poles, and no deserts as we know them. The Earth's temperature was stable, its air thick with moisture and carbon dioxide. Life thrived in that greenhouse world, but balance never lasts forever. Deep beneath the oceans, tectonic plates shifted, opening rifts and closing seas. Volcanoes rose, releasing carbon into the atmosphere. Mountains climbed higher, their growing peaks altering the paths of wind and rain. Each change was slow, but together they began to reshape the climate, setting the stage for the Earth's next great transformation. At the heart of this shift was the silent movement of continents. Africa drifted northward toward Europe, squeezing the ancient Tethys Sea into extinction. India, already on a collision course with Asia, was drawing closer every million years, carrying with it a vast island ecosystem. When the two finally met, the impact would fold the land upward, birthing the Himalayas, a mountain range that would change global weather patterns for tens of millions of years. South America remained an island continent for now, its animals evolving in isolation, while Australia continued its slow journey away from Antarctica, drifting into the southern Pacific, carrying with it the legacy of marsupials. As land masses moved, the oceans responded. Currents changed course, redistributing heat around the planet. The great conveyor belts of water that move energy from equator to pole were being rewritten. In the early Geocene, the poles were warm and wet. But as continental drift continued, new oceanic gateways formed, changing circulation. When Australia and Antarctica finally separated, a vast channel opened around the southern pole. Cold water began to circulate freely around Antarctica for the first time, isolating it from warmer tropical seas. The temperature of the planet began to fall. At first, the change was subtle. The forest remained lush, but seasonal patterns became more pronounced. Rainfall shifted. Where once every month had been green, now there were dry periods, times of scarcity that tested endurance. Some mammals adapted by migrating, others changed diets or behaviors. Evolution responded in small, steady steps. Fur became thicker in some regions, lighter in others. Species that had relied on stable climates learned flexibility. For the first time, survival meant adjusting not just to predators and food, but to weather itself. The drifting continents also shaped the geography of diversity. Isolation created unique ecosystems, each evolving in its own rhythm. In South America, marsupials continued to dominate, filling niches that placental mammals occupied elsewhere. Giant flightless birds became apex predators, while herbivorous mammals developed strange shapes and sizes. In Australia, similar stories unfolded. Marsupials diversified into everything from small insect eaters to large grazing animals. Meanwhile, in Africa and Eurasia, placental mammals were in full bloom, expanding into nearly every form imaginable. The separation between continents created an evolutionary experiment, producing parallel worlds that would one day collide again. These shifting plates didn't just move life geographically, they sculpted the face of the planet. New mountain ranges changed rainfall, creating rain shadows and deserts. Rivers altered course, carving valleys and depositing fertile plains. Lakes formed in rift zones, becoming cradles of life, where species flourished in isolation. Each geological change left its mark on evolution. The Earth was like a slow artist, painting with pressure and time, while life responded to every stroke. One of the most significant results of this tectonic restlessness was the creation of grasslands. Before this time, the world had been dominated by forests, but as climates cooled and dried, open areas began to spread. Grasses evolved to thrive under grazing and drought, their roots deep and resilient, their leaves narrow and efficient. Mammals, in turn, adapted to this new landscape. Herbivores developed high-crowned teeth for grinding tough silica grass, limbs lengthened for running across open terrain. Predators evolved speed and endurance to chase them. The dynamic between plant and animal reached a new level of intensity, and the first hints of the Great Plains ecosystems were born. The mammals that roamed these transitional worlds had to be ready for constant change. Their migrations expanded, following shifting vegetation zones. Some species became nomadic, their movements tied to the rhythm of seasons. Others remained rooted but adapted physiologically, hibernating through cold or conserving water through dry spells. Diversity exploded because every challenge opened new possibilities. The slow dance of continents, invisible day to day, created endless variation over millennia. As the global climate cooled, some regions faced more dramatic changes. Antarctica, once forested and green, began to freeze. Ice formed at its poles for the first time in tens of millions of years. The oceans cooled with it, their chemistry changing. Marine life shifted, favoring species that could endure colder, nutrient-rich waters. Whales, already evolved from their land-dwelling ancestors, adapted beautifully to this transformation. They became larger, their fat stores insulating them against the chill, their migrations stretching across entire oceans. What had begun as small mammals exploring shallow coasts became the largest creatures to ever live. The rhythm of the Earth's cooling had found a counterpoint in their song. In northern latitudes, forests gave way to temperate woodlands and open spaces. Deciduous trees replaced evergreens, dropping leaves in winter to conserve energy. The ground became covered in seasonal carpets of color, green in spring, gold in autumn, bare in the cold months. For the first time, the mammals that lived there experienced the full cycle of seasons as we know them today. They learned to prepare, to store, to migrate. The predictability of the year became another layer of adaptation, one that shaped memory, behavior, and even time perception. During these long transitions, evolution didn't slow, it accelerated. The constant flux of climate created cycles of isolation and reconnection. When seas rose, populations separated. When the seas fell, they reunited. Each cycle brought genetic mixing and divergence, driving creativity in life's designs. Mammals became increasingly specialized, but also increasingly intelligent. The ability to learn and adapt quickly became more valuable than any single trait. The world was entering a state of movement, not just in its rocks and water, but in its living beings. Migration routes became highways of life. Birds crossed hemispheres, whales spanned oceans, and herds moved in vast waves across continents. The planet's biosphere pulsed with motion. For mammals, this movement meant opportunity, but also pressure. Every species that thrived did so because it could keep pace with the shifting Earth beneath it. The dance of climate was not a steady waltz, but a series of improvisations. Volcanic eruptions could darken skies for years, cooling the air. The release of greenhouse gases could reverse the trend, warming it again. Each fluctuation tested life's resilience. The mammals adapted by refining the systems that made them unique: internal warmth, complex senses, social bonds, and intelligence. These weren't just accidents of evolution, they were answers to a world in motion. In the Miocene, temperatures rose briefly again during what scientists call the Paleocene-Eocene thermal maximum. Methane released from ocean sediments triggered rapid warming, and ecosystems shifted almost overnight on geological scales. Forests returned to high latitudes and tropical species spread northward. Mammals followed, their fossils found today in places that would now seem inhospitable. When the warming receded, cooling returned with even greater force. These cycles of expansion and retreat became the heartbeat of the Cenozoic era. Africa's northward drift eventually led to its connection with Eurasia. When the two landmasses met, species from each continent crossed paths for the first time. New predators arrived, new prey migrated, and entire ecosystems merged. It was a wave of competition and renewal. Those that adapted to the newcomers flourished, others vanished quietly, replaced by those better suited to the changed balance. Each collision between continents was a biological reset, a reshuffling of the deck that ensured no single lineage would ever hold dominance for long. South America, still separate, continued its own unique experiment. Its marsupial predators hunted strange hoofed herbivores, and giant flightless birds ruled the open plains. Isolation created both innovation and vulnerability. When, millions of years later, the island of Panama would rise and connect it to North America, the resulting exchange would alter everything. But that was still far in the future. For now, it remains a world apart, a reminder that evolution's path depends as much on separation as on connection. The mammals of this drifting, dancing Earth were no longer merely surviving, they were shaping their environments actively. Forest mammals pruned and dispersed vegetation. Burrowers aerated soil and regulated its moisture. Grazers maintained open lands that encouraged grass growth. Life was no longer reacting to the planet, it was participating in its design. The Earth had become a co-creation between geology and biology, an intricate feedback loop where each influenced the other. Even the skies were changing. Atmospheric circulation shifted as continents moved. The positions of mountains determined where rain fell and where deserts formed. The Sahara's earlier seeds may have been sown in this period, born from the same tectonic forces that built the Alps and the Himalayas. The dance of continents was creating patterns that would last for millions of years, setting the boundaries for ecosystems and migration routes that persist today. In this dynamic world, mammals learned to anticipate. Their nervous systems, honed by sensory evolution, became tools for prediction. Smells on the wind warned of approaching weather. Memory of past seasons guided migration. The growing complexity of their brains mirrored the complexity of the planet's systems. Life had reached a new level of awareness, not self-consciousness as we understand it, but a sensitivity to patterns, an ability to sense change and act before it arrived. As epochs passed, the Earth's slow movements continued their unseen choreography. The continents kept their pace, mere centimeters a year, yet enough to rearrange oceans, shift winds, and rewrite the map of existence. Mammals adapted with every step, each generation inheriting a slightly different world from the one before. The result was not chaos, but harmony, a dynamic equilibrium that sustained life through endless transformation. The age of drifting continents and dancing climates was not an age of stability, but it was an age of creation. Each change brought loss, but also opportunity. Each movement carved new paths for evolution to explore. Mammals, with their warmth, intelligence, and adaptability, were the perfect partners for such a world. They did not resist the Earth's motion. They moved with it, adjusting their rhythms to match its slow, perpetual dance. And though they could not know it, these movements would one day shape not just their bodies, but the very environments that future civilizations would inherit. The placement of mountains and rivers, the richness of soils, the boundaries of continents. Every step they took across shifting ground was part of a story still unfolding beneath our own feet today. As the planet continued its ancient, graceful motion through time, as the continents continued their slow drift, and the climate found its long, rhythmic pulse of cooling and warming, the world began to breathe in a different tempo. The lush, tropical expanses of earlier epochs gave way to new landscapes, open grasslands, temperate forests, rolling plains, and vast tundras. The air grew drier in places, colder in others, and the Earth's warmth now came in cycles, swelling and fading in long geological breaths. Out of this changing rhythm, evolution began a new movement, one of size, endurance, and strength. It was the return of the giants, the age of the megafauna. The mammals that had once been small and cautious, shaped by the need to hide and survive, were now bold, immense, and powerful. It wasn't that they sought to dominate the Earth, it was that the conditions of the planet invited them to grow. With cooler temperatures and open environments came the need for larger bodies that could retain heat, travel long distances, and access new kinds of food. The same slow changes that had reshaped oceans and mountains now sculpted life into colossal forms. The ice ages had not yet reached their full force, but their approach could already be felt. The air cooled at the poles, ice crept across mountain peaks, and sea levels began to shift. The once uniform world of warm forests fractured into regions of contrast. In the equatorial belts, rainforests remained thick and humid, but beyond them, grasslands spread like green seas, dotted with groves and watering holes. The mammals that roamed these spaces were the largest since the dinosaurs, massive herbivores that moved in herds, their heavy steps leaving paths across the plains, and the predators that followed them, swift and enduring. In Africa, vast herds of early elephants wandered across the savas. They were not yet the elephants we know, but their lineage was unmistakable. Long tusks, column-like legs, and intelligent eyes. Their distant ancestors had been small forest dwellers, but as the environment opened, they had grown. Larger bodies meant fewer predators, greater range, and the ability to travel for days without food or water. Their social structures evolved in parallel. Herds were led by matriarchs whose memory guided them to hidden springs and safe valleys. The wisdom of experience became as important as strength. Alongside them grazed other giants, early relatives of rhinos, hippos, and antelope. Some species grew to sizes that today seem impossible. Massive browsers that could strip entire trees in minutes, or grazers that moved in herds, thousands strong. Their feeding shaped the land. As they roamed, they opened the soil with their steps, spread seeds in their dung, and maintained the grasslands that fed them. Life had entered a feedback loop where animals and the environment co-created one another. The Earth was no longer ruled by a few dominant species, but by entire systems of interdependence, each one alive with motion. In Eurasia, the forests thinned as colder climates took hold. Here, the megafauna were adapted for endurance in the chill and snow. Mammoths appeared, their bodies covered in dense wool, their tusks curving long and elegant. Their ancestors had once grazed in temperate forests, but as the ice expanded, they followed the grasslands that grew in its wake. The mammoth's thick, fat layers, specialized teeth, and social behavior were perfect for the challenges of this new world. They traveled in family groups across the frozen steppes, migrating with the seasons, following the cycles of growth and thaw. Predators followed these great herds. Saber-toothed cats prowled the edges of the plains, their massive fangs designed not for chewing, but for striking precise, fatal blows. They were ambush hunters, relying on stealth and timing rather than endurance. Alongside them were dire wolves, larger, heavier, and built for cooperation. These early canids hunted in groups, communicating through subtle signals and calls. Their success was tied not only to strength, but to unity, a trait that would become a defining characteristic of their lineage. Further south, in the jungles and wetlands, other giants thrived. The early ancestors of tapirs, sloths, and armadillos spread across the continents of South America, evolving into forms that filled every niche. Some, like the giant ground sloths, reached sizes comparable to modern elephants, using their enormous claws to pull down branches. They were slow but unthreatened, their size a defense in itself. Even after millions of years of separation from the northern continents, these South American ecosystems rivaled any in diversity and wonder. In Australia, isolation had led evolution down unique paths. Marsupials had taken on the roles that placental mammals filled elsewhere. Massive kangaroos, thick-limbed and powerful, bounded across dry plains. Giant wombats and diprotodons, relatives of today's koalas, browsed in forests and grasslands. The largest predators were marsupial lions and giant flightless birds, descendants of creatures that had survived since the age of dinosaurs. The pattern was universal. Wherever life found space, it filled it, scaling up to meet the challenges of the landscape. The emergence of large mammals was not a simple matter of opportunity. It was also a matter of physics and biology. In colder climates, large bodies retained heat better. In open spaces, long limbs and endurance allowed animals to travel vast distances in search of food. In ecosystems where food sources were patchy but abundant, it was more efficient to be big. The planet had entered a phase that favored scale, and life responded with majesty. The diversity of these giants was extraordinary. Some were slow, grazing endlessly. Others were swift, built for bursts of speed. Some lived solitary lives, while others formed complex herds with hierarchies and relationships. Social behavior grew more intricate with size because cooperation offered protection and efficiency. The communication systems of these animals, low rumbles, calls, body gestures, spoke of intelligence and emotional depth. Herds cared for their young, mourned their dead, and remembered roots and watering holes over generations. The predators that hunted them evolved to match their scale. Saber-toothed cats perfected ambush hunting in forests and tall grasses. Packs of early wolves and hyenas developed endurance hunting, chasing prey until exhaustion. Bears grew massive, balancing omnivory and strength. Even flightless birds joined the ranks of hunters, their size and speed making them formidable. The age of the megafauna was one of balance, a delicate equilibrium between prey and predator, abundance and adaptation. As the Pliocene and Pleistocene epochs unfolded, the Earth's climate grew increasingly variable. Glacial cycles began, the slow, rhythmic advance and retreat of ice sheets that defined the coming millions of years. With each expansion of ice, sea levels dropped, exposing new land bridges. Populations crossed between continents, mingling species that had evolved separately. When the ice retreated, seas rose again, isolating them once more. These alternating connections and separations acted as evolutionary laboratories, constantly remixing life. The effects of these cycles were profound. Each glacial advance forced animals to migrate or adapt to colder conditions. Some developed thicker fur or greater fat reserves, others moved southward, following warmth. The ones that could not move or change vanished, leaving room for new forms to emerge. Extinction and creation became two halves of the same process, shaping life into ever more resilient forms. By the height of the megafauna age, every continent had its titans. In North America, mammoths, mastodons, bison and giant camels roamed the plains. In Europe and Asia, woolly rhinos grazed beside mammoths and steppe horses. In South America, armored glyptodons rolled across the lands like living tanks. In Australia, enormous marsupials shared the land with towering flightless birds. The planet, once empty and recovering from extinction, now teemed with life so immense it reshaped the land itself. The presence of these giants transformed ecosystems. Their grazing maintained open habitats, their dung fertilized soil, spreading nutrients far beyond their feeding grounds. Their deaths provided food for scavengers and decomposers. Even their movements changed the physical landscape, carving paths that rivers would later follow, compacting soil in ways that affected plant growth for centuries. The world was alive not only in its organisms, but in its constant exchange of energy, form, and motion. These animals were not only large, they were enduring. Many species lived for decades, passing knowledge through generations. In herds of mammoths or elephants, the memory of migration routes and seasonal shifts was shared and remembered. The same wisdom that had guided small mammals through darkness millions of years before now guided giants across entire continents. Intelligence had scaled with size, and emotion had grown with it. Care, cooperation, and even social mourning became part of their existence. But beneath the balance, change was stirring again. The same cycles that had nurtured these giants would eventually test them. As the ice ages deepened, temperatures swung more dramatically. The spread of grasslands reached its peak, but forests began to retreat. In some regions, drought replaced rain. Food sources shifted, and the once ideal conditions for massive animals became precarious. Large bodies, once a strength, became a liability when resources dwindled. Still, they endured. For millions of years, the megafauna weathered the fluctuations of climate, surviving through adaptation and persistence. Their age was one of grandeur, but not excess. Each species filled its role, balanced by the others. No single group dominated entirely. Diversity remained the planet's greatest ability. It is humbling to imagine those landscapes now, the slow, steady herds, crossing plains under vast skies, predators trailing at a distance, birds circling overhead. The air would have been thick with sound and scent, a living orchestra of movement and energy. The ground itself might have trembled beneath their steps. Every day was a continuation of ancient rhythms, unchanged since the beginning of life's expansion. In time, the world's temperature dropped further. Ice advanced again, reshaping coastlines and forcing migrations southward. Some populations became isolated, their numbers dwindling. Others adapted magnificently, growing thicker coats, storing more fat, or altering their diet. But the cycles were relentless, and each new glaciation brought greater strain. Eventually, another kind of mammal would step onto the stage. A smaller one, upright and curious, whose mind would alter the balance in ways no natural force ever had. But in this moment of the megafauna's reign, the Earth belonged to them. The giants roamed freely, their presence an echo of the world that once had been, and a prelude to the one that was coming. They were the Earth's slow heartbeat made visible, the culmination of millions of years of evolution, finding harmony with geology and climate. They were not just survivors, they were the living memory of the planet itself, carrying forward the strength, warmth, and persistence that had defined the story of life from the beginning. And as the glaciers crept down from the poles, the winds grew colder, and the continents continued their long drift toward the shapes we know today. The giants continued their patient wandering, unaware that they were living in the final chapter of their great age, unaware that soon the world would change once more. The world that the giants had built was beginning to quiet. For millions of years, the rhythm of hooves, tusks, and massive footsteps had set the tempo of the earth, a deep pulse echoing across plains and valleys. But now that rhythm began to slow. The ice ages had come and gone in cycles, carving their mark on the planet's surface. Each wave of cold reshaped the world, erasing forests, drying rivers, shifting winds. When the warmth returned, life recovered, but each recovery was smaller than before. The megafauna endured through countless winters and thaws, but even endurance has limits. The giants that had once ruled through patience and strength were facing a new kind of change, one too swift and subtle to sense until it was already underway. The planet had entered the late Pleistocene, and the climate was becoming erratic. Ice sheets advanced and retreated in unpredictable rhythms. Sea levels rose and fell, isolating populations and cutting off migration routes that had sustained them for millennia. The delicate balance between species, temperature, and vegetation began to wobble. Where once lush grasslands stretched endlessly, tundras expanded. Forests migrated southward and deserts grew. The herds that had once roamed freely found their feeding grounds shrinking. Predators followed their movements, and scarcity rippled through the food web. And yet, even in these transformations, life persisted. The mammals had learned over tens of millions of years how to adapt to flux. Some grew smaller to survive on less. Others became more efficient in their foraging, more selective in their diets, or more social in their survival strategies. The intelligence that had been quietly building since the dawn of the mammals now became their greatest asset. In a world where everything changed, memory, learning, and cooperation offered a kind of stability that the environment could no longer guarantee. Among the changing landscapes, a new presence began to spread, subtle at first, then unstoppable. It was another mammal, small compared to the great beasts around it, but with a strange capacity that none of the others possessed in such depth. Foresight. It could imagine, plan, and alter its surroundings intentionally. Its hands were not just for grasping, they could shape and build. Its eyes were not just for seeing, they could envision what was not yet real. These early humans were still part of the same great continuum of life that had produced mammoths and lions, but they carried something within them that would soon tilt the balance entirely. Long before their tools or fires changed the land, these humans were part of the megafaunal world. They lived alongside mammoths, hunted bison, and watched the skies for signs of weather. They shared the earth with saber-toothed cats, bears larger than any seen today, and herds that stretched to the horizon. They were observers first, learning the patterns of migration, the behavior of prey, the subtle language of seasons. Their survival depended on understanding others, their rhythms, their movements, their instincts. Every hunt, every fire, every shelter built came from that understanding. The relationship between humans and the megafauna began in balance. Early hunter-gatherers took only what they needed, their numbers small compared to the vastness of the wilderness. The ecosystems absorbed their presence easily. But over time, as populations grew and tools evolved, that balance began to shift. Hunting became more efficient. Spears, traps, and cooperation allowed humans to challenge even the largest animals. Fire was used to shape the landscape, clearing vegetation to attract game or promote new growth. The quiet inheritors of the future had begun to alter the natural order, not through strength, but through thought. While human activity was still local, the climate continued its own unpredictable dance. The last great glacial period reached its peak around 20,000 years ago, covering much of the northern hemisphere in ice. The weight of these glaciers depressed continents, lowering sea levels and connecting lands that are now separated by water. Across these temporary bridges, humans and animals moved together into Europe, Asia, and the Americas. The migration of life reached its most global form yet. Then slowly, the ice began to retreat again. The planet warmed, and the great sheets melted back toward the poles. Rivers swelled, coastlines shifted, and entire ecosystems flooded or vanished beneath rising seas. The thaw released water, but it also released instability. Plants changed distribution. The grasslands that had supported massive herds began to fragment. Forests reclaimed ground in some regions, while others turned to dry plains. The megafauna, adapted to vast open spaces and abundant resources, found themselves confined to shrinking refuges. The combination of changing climate and human expansion proved more than many species could bear. It was not a sudden catastrophe like the asteroid impact that ended the dinosaurs. It was a long, drawn-out attrition. Each generation faced slightly fewer resources, slightly more pressure. Populations dwindled gradually, unnoticed at first. By the time the loss was visible, it was already irreversible. The mammoths, mastodons, giant sloths, saber-toothed cats, and countless others slowly disappeared from one region after another. Their extinction did not happen everywhere at once. In Africa, where humans and large mammals had evolved together, many species survived. The balance there was ancient, shaped by mutual awareness. But in regions where humans arrived later, Australia, the Americas, northern Eurasia, the local animals had no evolutionary memory of such predators. They did not recognize the quiet hunters with fire and tools as a threat until it was too late. The result was a wave of extinctions that swept across continents, leaving behind silence where thunder once rolled. Yet the disappearance of the giants did not end the story. The world they left behind became the foundation of the one that followed. The ecosystems they shaped endured, transformed, but still alive. The grasses they had maintained continued to spread, forming new savannas. The forests they had pruned regrew in layers of new diversity. The nutrients they had cycled through the soil remained, feeding the next waves of life. Even in absence, the megafauna continued to shape the earth. The smaller mammals, deer, antelope, wolves, foxes, and primates expanded into the spaces left behind. Their agility and adaptability allowed them to thrive in the new mosaic of environments. With fewer massive competitors, they diversified rapidly. The Ice Age giants had carried the torch of endurance. Now, the smaller, quicker, and more flexible species carried it forward. The Earth had entered a quieter age, but not a lesser one. It was an age of subtlety, of intelligence over scale. For humans, this world of change became both a challenge and opportunity. They learned to herd animals instead of only hunting them, to cultivate plants instead of merely gathering them. The first seeds of agriculture were planted in soil enriched by millennia of animal movement. The rivers that had been fed by melting glaciers became cradles of civilization. In a sense, the quiet inheritors were not only the humans themselves, but the landscapes they transformed, the fields, the forests, the rivers shaped by intention. The story of the mammals did not end with the extinction of the giants. It simply changed focus. The large forms gave way to smaller ones, but the same principles continued: warmth, adaptability, and care. The intelligence that had guided survival now guided creation. The mammals had once roamed according to the will of climate and geography. Now, one lineage began to roam according to imagination. But even as humanity advanced, the same biological rhythms remained: the warmth of the body, the need for touch, the bonds of family, the communication of sound and scent. Beneath the new layers of technology and thought, the ancient mammalian patterns continued quietly. All around the world, animals adjusted to the new human presence. Wolves followed human settlements, scavenging and eventually forming partnerships that would become the bond between dog and person. Cats, once solitary hunters, began to live near the edges of early villages, drawn by the promise of food. Rodents and birds adapted to new sources of grain. Life, as it always had, found a way to coexist, to find balance in motion. The planet was changing faster than ever before, but its underlying story remained the same. If one could have stood on the plains of the late Ice Age, and then again in the early days of civilization, the difference would be striking. The giants would be gone, their bones buried beneath layers of sediment. The herds of smaller animals would graze quietly where mammoths once thundered. Human figures would move across the same land, carrying fire, tools, and stories. The echoes of the megafauna's footsteps would still be there, faint but enduring, woven into the soil itself. The world had not forgotten them. Their disappearance was not a vanishing into nothingness, but a transformation into memory and influence. The climate they helped stabilize, the ecosystems they balanced, and the patterns of life they maintained continued long after their bodies were gone. Even the humans who outlived them carried their image forward in cave paintings, carvings, and myths. The mammoth and the lion, the giant sloth and the bison lived on in imagination, preserved as symbols of a time when the Earth's wilderness was vast and alive. The quiet inheritors of the future were those who remembered, even unconsciously. Every species that survived carried the legacy of those that came before. The adaptations refined in ancient forests, the warmth invented in shadowed burrows, the senses sharpened through darkness and dawn. The mammals had inherited a planet once ruled by giants, and they would, in turn, pass it on to others. The Earth was never static. It was a chain of continuities, each generation writing its story upon the remains of the last. Even as humans built settlements and began to shape the world through intention, the lessons of the past were still written in their biology. The need for warmth, the comfort of touch, the instinct to nurture, the ability to learn. These were not inventions of civilization, but inheritances from the deep history of mammals. The same hidden power that had once driven evolution through the darkness now guided a species toward reflection, art, and thought. The planet itself continued to change beneath them. Ice receded further and new coastlines formed. Forests spread into areas that had been frozen tundra. Deserts grew in the rain shadows of rising mountains. The continents reached the shapes we recognize today, but their slow drift continued. The same unseen motion that had shaped the history of every creature before. The Earth was still dancing, its steps too slow for any one lifetime to notice, yet relentless in their rhythm. In the new age that followed, life would never again be as it was during the reign of the giants. But the spirit of that age remained. The endurance, the cooperation, the quiet intelligence, all persisted in new forms. The mammals had inherited the planet from the reptiles, and now humanity had inherited it from them. The continuity was not about domination or succession. It was about persistence, the ongoing conversation between life and Earth. If one listens closely even now, to the wind moving through the trees, to the heartbeat beneath the ribs, to the quiet awareness shared by every living thing, there is still the echo of that long journey. The warmth that once protected a small creature in the night, the senses that guided it through danger, the soft skin that carried connection forward, all remain within us, reminders of a lineage that stretches back to the first heartbeat of life. The quiet inheritors of the future are not just those who walk upright or build cities. They are every being that carries this ancient flame, every species that continues to adapt, endure, and respond to the ever-changing Earth. The world remains alive with their motion, their breathing, their warmth. The story of mammals is still unfolding, one generation at a time, in the same steady rhythm that began long ago when the world was dark and life was small, and everything depended on a spark of warmth within. And as the Earth turns, as continents still drift slowly across the face of the sea, the descendants of those quiet survivors, humans, elephants, wolves, whales, and countless others, continue to move with it, unaware that they are part of the same ongoing dance that began when mammals first looked toward the light and stepped from the shadows of another age.